Welcome to the Spreadsheets and DataFrames tutorial. I am Ryan. I will be your guide for the next 3 hours. Hopefully everyone is ready to learn some Python. So I'm going to share my screen here. How do I do that? Let's see here. I practiced this beforehand, but I still need some walkthrough. Okay, so for all of people, if you're interested in what we're going to talk about, I've broken this into 3 sections. Section 1, I call the basics. It's going to be probably about 60 minutes, and we're going to jump through, some important stuff in Python. Again, this tutorial is kind of geared towards, an Excel user who's interested in learning Python. What are the kind of the, important stuff to know? What are the differences between Excel and Python that you might want to know? That's really what I touch on in the first section. So I really recommend people watch it. And if you got to rewatch it. I think I touch on some of this, a little bit of my background. I before I got into Python, I spent 8 years. I was an investment analyst, working in Excel all day, and I pretty much opened Excel every day that I went into the office. I was doing modeling, I was doing data analysis, visualization in Excel. And so eventually, to talk about, I kind of got to the point where Excel was a little bit, there's some limitations on what I could do and like how fast I could process data. Maybe I was throwing too much data at it, or I was doing it ineffectively, probably something I did wrong, but and so that kind of led me to learn, kind of branch out. And that's how I kind of found Python. I've spent the last 8 years working in Python for the most part. What this talk is basically about is kind of that trip, the journey that I've been on the last 8 years is kind of, what did I do to kind of get to the point where I'm at now, tips and tricks, for potential Excel users. So the first section, like I said, we're going to cover some basics, but important basics. In the second section, we're going to actually do a real world Python example. We're going to find a data set on GitHub. It's the SEC data set. It's actually the same data set that I use to learn Python. But we'll walk through that process from beginning to end. We'll basically create a little app that downloads the data, transforms the data, and do this as a visualization. And yeah, that's going to be the second section. It's going to be around 60 to 90 minutes, depending how much, we'll get through. And then the third section is going to be best practices. And that's going to be around 30 to 60 minutes, kind of like, how to organize data effectively, talk about a workflow, understanding kind of the process, and then I do a little Airflow demo, which is really cool program for scheduling stuff. And I use Docker and instructions for getting all this set up are in the GitHub repo. And yes, best practices. All right, so let's go. Let's see here. Let's get this started. So I am going to get this. So we've got everything is in the GitHub repository. Hopefully everyone's already cloned it, but if we scroll down a little bit, we have access to the slides. This is the first section I'm going to talk about. I don't really talk about, I kind of just went through the introduction, but you can look at it if you want. We talk about the data management. And in this first section, we are going to be, this is going to be the first section we're going to talk about, but here's the code for the tutorial. Here are some from my old talks, some more Jupyter notebooks, installation instructions, installation instructions for Docker. And at the very end, I kind of have a bunch of just like links to all of these resources I've used over the years that I think are really good. A lot of books, links to those. There's a bunch of GitHub. I'm going to probably add more stuff to this, but there are some really great tutorials on introduction to Python that, are definitely worth watching. I'd probably do a better job than I'm going to do. but yeah. So then I talk about some of the packages that we're going to use. Cookie cutters are awesome. I talk about them. We're going to talk about some requests, and also in this in the repo or in the README, I kind of thought about like, request is a pretty no, it's easy, but it's a pretty simple library to use. And so what I found is that after I kind of mastered requests, I was looking for new challenges. So I kind of thought about that. And if you're looking to kind of take the next step in requests, you should definitely check out, multi-threading, concurrency, async IO, message queues, parallelism. And there are some interesting articles that you might, kind of introduce you to the subjects. And so I do this for all of these pandas, a bunch of great tutorials that you should check out. And a link to kind of, the next steps, maybe Dask or Spark might be interesting. Visualization, links, and then, maybe go JavaScript or D8.3 or something, and Flask. And so these are kind of the main packages I'm going to talk about in the second section. The first section is where we are just going to do plain old Python, which is, I think, really important if you really want to kind of get good, especially at Pandas, is to kind of learn to understand at least the basics of this stuff. And so I personally, everyone has got their own opinion on IDEs. I personally like PyCharm. Other people like VS Code. Other people like Notepad. That's fine. You can use whatever you want. And so I am going to, I like to save my stuff in my C projects folder. And then, we can jump into I actually think I cloned this to my, yes, I probably did. So I actually had this in my temp folder because I was testing it out earlier. So yes, but we can go into here and we can go into spreadsheet. This is how you know it's live. And so we are in here, and if we look at the instructions, it says running Jupyter notebooks, navigate to spreadsheet. Okay, we're in the spreadsheet folder. We're going to activate spreadsheets to DataFrames. Hopefully I have that set up. Oh, I don't have it set up. So we're going to follow these instructions real quick. So we are going to install some packages. We're going to create an environment. It shouldn't take too long. And so what this is doing is installing all the packages we need. Let's see here. Yes. And so that's going to install, and it's awesome. Let's see here. And so what kind of is, and I actually talk about this in the slides, which I am going to talk about while we get this installed. All right.
Oh, and real quick, Ryan, I'm sorry. When you have the console open or whatever, can you increase the size of your font?
Oh, yeah.
Thank you.
Yeah. And if anybody doesn't really look with it. All right. So we're going to, while that installs, we're going to go through some slides here. And transition slideshow from beginning. All right. So again, for this first section, I'm going to touch on a lot of basics, and I'm really going to focus on, this again is focused on, an Excel user coming to Python. So what I did in this first section is try to explain stuff in an Excel terms and try to try to kind of map that towards the Python equivalent. And so that's kind of what this first section of the slideshow's on. So if we think about just starting the application, like we just saw, with Excel, we can click the Excel button or the Excel icon to start the program. With Python, we've got a couple different options to start the program. We can go into console and type Python. Or if you have Anaconda installed, Anaconda Navigator is actually really a cool and I found really helpful way to understand environments. So maybe that's something that you can make use of. It's got a GUI. You can go in and launch stuff. You can launch Jupyter notebooks. You can manage environments. And I definitely, if you're newer to Python, I definitely recommend checking out Anaconda Navigator and Anaconda in general to install packages. And so once you kind of get everything set up, and and maybe you're looking for, okay, you've used Jupyter Notebooks. Maybe the next step is using an IDE. An IDE is a basically kind of a way that you work with code. And this is a picture of Visual Studio Code. Again, I use PyCharm. People like using whatever they feel comfortable with. So interacting with the environment. So the way that I try to explain this for people is that, with Excel, you're clicking and you're typing, but you're clicking a lot. You're just going to have to get used to using the keyboard and kind of, you can kind of think of it as clicking in Excel and you type in Python. And so that's the way I would recommend it. So here's a Excel, we might go up to, one of these buttons and click, the fill button, or might go in there for, change the font or something. You're clicking, but with Python, you're kind of stuck with this if you're going to use an interpreter, you're like, okay, well, how do I do this? And that's really how an IDE really helps. It really helps. And I definitely recommend everyone use one or learn one. Again, this is Visual Studio Code, but that's really how a lot of people interact with Python. And so this is an example of a simple program that opens a file, prints out the file, and with the IDE is that you can kind of run this code and do it interactively. I really like PyCharm, and cool thing about PyCharm, and especially with Python, is this interactive terminal. And I recommend that everyone use the interactive terminal as much as possible to work with, especially with pandas and data, anything. It really is like instant feedback on and it's kind of unique to Python. Some of the other programming languages are adding this functionality because they've kind of seen how awesome Python is. And so now use the interactive terminal in the second section, but I definitely recommend checking these out. All right, so now to kind of the data. If we think about Excel, we are working with cells, and we basically go in and we type in, the numbers, we hit enter, and they kind of are stored in, this might be cell A1, might be cell A2, A3. And so we can reference those cells later when we want to do calculations. So with Python, you can kind of think of a cell as kind of like a variable where you're storing data. And so, the equivalent to the picture on the left side and the right side in Python would be, we would set A1 equal to 260, A2, and so on. Don't include commas, talk about that later, but strings, you have to put quotes around, and then trues, we'll talk about this later, but trues are title cased. And so just like a little tip, in Python, we get to name our variables whatever we want. I know you can do this in Excel, but maybe better names for something like this might be stock price, revenues, ticker, or public company. And so I talk about this later, but there's a guide on best practices on naming stuff in general, underscores. So yes, keep that in mind. So comments. So in Excel, you can do comments. In Python, you can do comments. Comments are little pound signs. I use them a lot. You can also comment with three triple quotes, and that's called a multi-line comment. And so if I run this code, it doesn't affect the code. Yes, just be aware of comments. Yes. Keywords. All right, so keywords are words in Python that you probably shouldn't use as variables. You can, but you probably shouldn't. I think you can. I'm pretty sure you can, but you overwrite the functionality. So, over time, you're going to learn these keywords. You don't have to memorize all of these, but you'll eventually learn them like I did. After, here's the if statement. Here's the def for defining a function, and, or. So again, it's something that you'll pick up on over time. All right, so if we think about Excel functionality, we've got these things called built-in functions. And these built-in functions have got syntax. And this is basically, I think this is from the dummy site, Excel for Dummies. And, but it's a good example of how a function works in Excel. And so basically, if we wanted to find a function in Excel, we have to specify the function name, and then in parentheses, we got to give it some input. And so what you find in Python, it's almost exactly the same. There are actually built-in functions that are exactly the same between Python and Excel. But just this is a built-in function. And so if we were going to do a function, maybe in Excel, we might bring up, the insert function. We might select sum. We might do this 1 and 2. Okay, sum. And so this is, an example of doing a sum function, sum at 3. Right, we can see the function here. And so if we think about kind of some of the built-in functions that I use or I've used in the past, sum is a pretty one, count, round, if. These are kind of some functions that, I make use of a lot in Excel, and specifically text functions. If I want to get the left of something or concatenate, replace, lower, upper, the length, these all are built-in functions in Excel. And so luckily, Python has got built-in functions too. And so they have a lot of the same functions. You just have to know about them, basically. And you learn this stuff over time, and after kind of practice, you kind of like, oh yeah, there's a built-in function to do some of this stuff, right? So I'm going to highlight some of the math functions, right? I don't think len is a math function, but sum, max, round, min, absolute value. So these are just built-in. You don't have to do anything. If you open up your interpreter and you start typing these, they will work. And you have to give it an input, and just like Excel. Some of the in the Jupyter notebooks in this first section that I'm going to talk about specifically are these 5. The help function, the input function, which lets you input data like, what is your age, and you can input 7. That's how you do that for like a little program. The length function is the length of a string. So we can figure out how long a string is, and you'll see why that's important. And print. And so when we think about like displaying data or displaying stuff in Python, print is a really, really, really useful function to know about when you're first starting out. And so because you want to see, you'll have variables and you want to see what those variables are. And print is just a really quick way to see what those variables are in your program. So you can kind of, continue building your program. And then the open built-in function, which is used to open files. And we talk about that in this first section as well, on how to open up. We use a CSV file, how to open a CSV file, and the steps involved in that. And so these are kind of, if I think about like what are the built-in functions I use the most, here is probably the most. Dictionary. This is a data structure we'll talk about in the first section. List we'll talk about. And ints and floats we will talk about in just a moment. We also talk about type. And so this is actually what I'm going to talk about in a moment as well. All right, so this is probably the most important slide in my whole presentation. And because it's kind of like a fundamental, and so everyone stop what you're doing, pay attention. If you're an Excel user, understand data types, right? So because they will help you later on, especially in Pandas. And so actually, so Excel has got this built-in function called type. And we can actually put values in it and see what type of data each of these values are. So if we put in type here, we're like, okay, well, this is probably pretty obvious. Again, this will make sense in a second, so pay attention. So this is a number. So in Excel, these data types are called numbers, right? Okay, that text, this is text, Microsoft text. Okay, so this is a true, this is logical. They actually have an error data type that's from this cell, and then we've got array data types, okay? All right, so Python has got data types as well. And as you'll see in a second, they are pretty important to know about. And so Python actually calls their data types for numbers. They differentiate themselves. There are more data types than I'm talking about here, but I'm going to let you learn those on your own because they are a lot of fun. And so if we look at what Python calls this one, it's called an integer. A float has got the little old dot in there. Python calls text strings. So kind of try to remember that. Strings And we call the logical functions true and false Booleans. We call these exceptions. Here are some examples of how you might initialize each of these different variables for each of these different types. So we'll talk about these in the second section, or in the section as well, as these array types. They've got a couple of them, and we've got more. But if we want to kind of have a group of values, a set, can contain unique values really fast. Tuples, I've got the parentheses, and they're also fast, but they're kind of strict on what you can do with them. Lists, we're going to talk about lists and dictionaries are probably the ones I use the most. I've got square brackets. You can put anything, pretty much anything in a list, and they're really useful. They're a little bit slower than some of the other data types, but they're really, they have a lot of give when you want to work with them, and they're used by square brackets. And dictionaries have got curly braces, and then they've got a little colon in between and a comma. And so this little one right here is called the key and the value. And so each key must be unique. The values can be the same, but this is just a small example of what a dictionary looks like. And again, we'll talk about this in a second. We can actually, we can convert different data to different types. So we could use, like, if we have a string that has got like a 1, we could use an int to convert it into an integer, and we can use it to convert into a float. So that's just something to know about as well. All right, so formulas. So basic operations with mathematics, very similar, a little bit different in the division. There's 2 slashes instead of 1, and you can check that out. We also have got comparison operators, which is pretty similar. We use 2 equal signs instead of 1. That's something to know about. And the not equal to is the exclamation point and equals. All right, so, and we're kind of flying through these, but again, these are important. Pre-installed add-ins. Okay, so this is another important concept to kind of, for an Excel user to understand. So Excel has got these things called Excel add-ins, and they come installed with Excel, but they're not necessarily enabled by default. And so what you have to do is you got to go to the little add-ins, and then you got to click the little check mark and then enable add-in before we can use. So once we enable the add-in, we can use the add-in. And so I just enabled it, and so now we can use the add-in. So Python has got pre-installed add-ins, but what they call it is the standard library. And in order to use modules in the standard library, we have to enable it, and we enable it by using the import statement right here, as you can see. So glob is a, and we use this in the second section, is a pre-installed part of the standard library that lets me search for file names on my computer. And so before I can use it, I need to import glob, and then I have access to glob to use it. And so that's a really important concept to kind of wrap your head around. Again, you gotta just think of Excel add-ins, pre-installed add-ins. You gotta enable it, and then you can use it. Okay. External add-ins, another important concept. Python calls them packages. So Excel has got this thing called the get add-ins. It's like the Office 365 store or whatever is what's called. And you can go to it and you can install a third-party add-in. So you can go and install, like, you say you want to install Bing Maps or something in Excel or Wikipedia. You can kind of, Office and Microsoft have got an app store where you can go to and download and add third-party libraries. And just click it, but you've got to search it out. You got to know it, and you got to install it before you can use it. Python has got something very, very similar. It's called the Python package index, and it is a place. It is the agreed upon. It's pretty standard where you get third-party add-ins for Python, and so you can go to the site. You can search for, in this case, I search for request, and it'll walk you through the installation, and it's got links to guides on how to use it. And so I am going to use third-party packages in the second section. So yes. And so here's example request, pip install request. This is how you install a package, and you open up your command line and you type pip install request, and it will install a package. And then, so here's an example of my terminal. We installed request, and then we can use it. So if you're using Anaconda has got a really cool like a GUI for kind of seeing the different packages you installed. And I definitely recommend people take a look at that if they're kind of newer and are trying to wrap their head around packages. Definitely check out Anaconda Navigator. You can actually use it to install packages. And maybe when I first started, I think I was using this to kind of manage packages because installing packages on the command line is too difficult for me. So definitely recommend checking that out. And so if we're going to use the request library we just installed, we've got to, for these internal, external added, we got to import request, and then we can use it. You got to make sure you import it first before you use it, or else you're going to get an error. And we talked about that. And so if we think about file types, Excel has got tons of file types you can open. Here's a list of all different file types you can open. Luckily, and so we have like Excel files, web pages, XML text files, databases, and also CSV files are in here somewhere. Yes, but you can also open CSV files. And so Python, you can open up those packages and a lot more. You can open up pretty much anything. Yeah, as long as you have permission for it, you can access it. And so you can open up PDFs, you can open documents, you can people do video processing with Python. So you can pretty much open anything. Again, it's the same. You just have to find the right add-in or package to work with those files sometimes. And so if we think about just like opening a file in Excel, we go to open computer, we find the program, and we open the file. Python is a little bit different. You're using your keyboard, remember? You're going to type. And so this might be a simple open function where we're going to open a file in Python. We give it a file name, and then we can specify, this is optional, but we can specify whether or not we want to read it or write to it. And we'll see an example of this later. But this might be a way you open a file. So that's kind of like the basic way. The more preferred way is to use the with open. I'm not going to get into what this means, but it's and this is where Python, you got to be careful with the indenting here. And I talk about this later. The colon here. Once you see a colon, you probably going to have to indent underneath. And so just be aware that this is a really important concept in Python. This white space here, if you have stuff on below this and it's not indented correctly, it should be all aligned underneath the colon. You'll get an error. And we talk about this later. And so with Python, you can display the data pretty easily. Like you type it in and it's already displayed for you. With Python, like I mentioned in the built-in functions, the print statement is your friend when you're starting out. And you can kind of, this example is opening up a CSV file with some data in it. It's got some tickers, and we're looping through. And yes, and Python, Excel has got date time, or Excel has got date time, and so does Python. They're good to know about. You eventually won't use them probably. And so here's some examples of, you can get like today, we can get a today object, and this will print out today's date. This is we can take a string of a date and convert it into a date object in Excel. We can do the same thing with Python. We can convert a string into a date object, and the date object has got a lot more functionality, and we'll talk about this in the examples in the first section. Okay, so data structures, if you think about Excel, they've got, this is an example of a column, and this is an example of a row, right? We've got some rows. So really want to think about when you're working with, if you really need some way to kind of grasp how data structures work, you can kind of think of them, just kind of remember what a row and a column and don't kind of, at least in the basic section, don't think about tables yet. And so we can kind of, if we wanted to represent this in a list, we might represent it this way. And here's a tuple. And so if you wanted to represent a tuple or tuple, that's how you would kind of create a tickers object with tuples. Dictionaries are a little bit different, and they're really, really handy for pandas, as you'll see, second section. You got to specify a unique key here. It can be almost anything, but and the values can be duplicates. But if you were to think about maybe these would be like the row numbers right here. Maybe that if you needed to kind of understand, kind of think about it, you might have these as row numbers, and then you can have the values as keys. So sets are a sequence of unique values. They can't change, and the values must be unique. Sometimes they're really useful for, if I have a bunch of numbers and I just need to find, and I want to get rid of the duplicates, sets are very useful. And so in Excel, we can perform a simple calculation by, so we have this data and we want to calculate profit, which profit for everyone is revenues minus expenses. So we want to take the sales column minus the expenses column, and that will give us a profit column. And so what we might do is create a new column here, total profit, create a new column, header, and then create the reference here. So we're going to do sales minus expenses, and then hit enter, and it's going to perform the calculation. And then what we can do is we can take that calculation and now fill down the values in Excel. And the reason I'm putting this out is this is almost exactly how Pandas works. So if you're interested in learning Pandas, take note here, because it'll help you kind of wrap your head around what Pandas is doing. And so once we do that, then the calculation automatically fills down. And it basically populates the data, and we have a new column. It's almost exactly like Pandas. And so, yes. And so this is also, so we talk about Pandas in the second section, but when I remember learning Python from Excel, one of the tough concepts for me was the concept of a for loop. They are really, really important. And so this is why I talk about them. They take practice, but once you get them, they're going to become second nature. But a for loop is kind of, you can think of it the same way as us going through that Excel calculation and filling that. We're going through each row one at a time and performing the calculation. And in this case, we've got this list designated by the square brackets, and we can use a for loop to go through one at a time and do some sort of calculation if we wanted to. So so we can use the for here. So for ticker, we can name this whatever we want. I like to name things what they are. So this is a ticker in the tickers. Maybe I should have called them this ticker list, but basically, and you see this colon, you see the we need the tab here underneath the colon. And what we're doing here is we're printing the ticker. We're using string formatting, which allows us to use a variable inside of a string. And we can see with the F, this is a newer way to use string formatting with curly braces. I talk about this in this per section in a second. But what this is going to do is it's going to print out, this is what it's going to look like if you ran this in your terminal. It's a simple example. Maybe every morning, if you're struggling with for loops, maybe every morning you wake up, get to your computer, just practice, write this, do like 100 times or something. And you eventually kind of get ticker, or you get for loops, understand the concept better. And so we actually use this in the example, but here's a kind of a little bit more of a little more complex example of opening some data with a CSV file, it's we can see that we have a colon here, so we need to indent. Remember indent, and so everything is aligned with the left side here, indented up. So we see another colon, and we got to indent one more time. And so all of this, so this is really important. This indentation, and I've got some examples in the first section and resources on how to better explain this. But basically, what this is doing, and it is basically the Walmart data we saw before. It's got about 10 rows of data, and so what this is doing is it's taking in a file name, it's reading the file name, and we're reading the with the CSV Reader, which I talked about, and it's going to loop through each of the rows. You can ignore this now, but you know, we're here. We know the first column is a date time object, or the second column is date, so we can parse that into a datetime object, and we can convert the row with the sales data into an integer, the expenses into an integer, and then we can perform a profit calculation, which is sales minus expenses, and this would print out the profit for just like we did in Excel. And this is what the output looks like. And if you want to look at the example, you can go to the link and check it out yourself, and you know, do it as much as you want. And so here's a little sneak peek of Pandas. We talk about this in the second section a lot, and Pandas is awesome because you can do stuff really easily with Pandas, and it's just like three commands. We got to import it. Pandas, we got to import it to use it. The PD is a little bit of a naming convention used in Python to kind of designate to make it easier to work with. And so we're giving it a file name, we're doing a calculation, and we're saving it to a CSV file. And this is what the output looks like. Really awesome. Pandas is really awesome. I definitely recommend people are using it. So we have error messages, and you know, this is what it looks like in Excel. You know, here's a bunch of different error messages. Here's how you figure out what your error messages, how you fix your error messages. You go to Google and you type in the problem that you're having, and it will tell you it'll tell you exactly how to fix it. But so Python has got error messages. It's usually the last line in the error message that you basically copy and paste this into Google, and you can get a million. Look, we have 5 million answers to this. And so if you have an error, just read copy the last line and just paste it into Google, and there's 17,000 different ways people will ask this question, and I'm sure you could find, if you've gotten this far, I think you can figure out how to fix an error message. So this is kind of installing Python, you know, the same thing, Python. You can go to the website, install Python. This is kind of like your vanilla Python. I actually like to use Anaconda distribution. And so you can go to the Anaconda site, get that, install it. And that is the slides. All right. So that is awesome. All right. So now we're going to flip over to, if you want to follow along, hopefully you can follow the instructions on the README. If you have any problems, let me know. So we created a environment, and we have that. And so if we go back to the after we've activated Spreadsheets, and we can install, this is how we install our third-party packages. And so we're gonna if we look at this pip install, or this pip requirements file, we can see a bunch of there's Pandas, NumPy. These are all the packages that I use throughout the tutorial. And so what I'm doing here is I gave it a command that says pip. If it's in Python, this is how you install third-party packages. It's going to read this file, and then whatever's in this file installed. So these are all the different packages that I'm installing. It's just a quick way, and the way that people, you know, install packages. And so got that installed. Now we can run the Jupyter Notebook, and I think this is the right command. Yes. So notice how I'm in the directory. I'm in the main directory here of the spreadsheet to DataFrames, and I hit the Jupyter Notebook. And so that's going to open up the Jupyter Notebooks in that directory. All right. And so we have all of our files here. What we're looking for in this first section is the section 1 basics, but important stuff. All right, so this first section, we've got about 15 minutes, and we're going to fly through some of the stuff, but, you know, luckily this is being recorded. And so with Jupyter Notebooks, we can run through it, and I've got a bunch of comments in here, and let's just kind of get started. So the command for, let me start this little program. I had a program, but I don't know what it is. All right, so hopefully, can everybody read this? Does that look good, everyone? Right. So we have here are the here's the section. So you heard me talk about comments. So in order to run these, you press Shift Enter, and this runs the code. And so these are comments. Comments don't affect the code, but I use them a lot to kind of like when I'm trying to figure out what the output is. I'm not going to cover everything in here, but I gave links. This is a really cool website I found that lets you run actually. This talks about the syntax, but like if statements or something that lets you actually run the code in the browser. So if you wanted to run some of this stuff, you can actually run it and make changes to it and cause like errors and stuff and crash the system or something. But it'll actually let you run in the browser. Okay, it takes a second though. So these are just kind of important concepts you can look at and on your own time. But I'm going to talk about a couple important things. So we're going to talk about different types of data types here. So quotes around strings, make sure you put those. They have to be the same, otherwise you're going to get an error. But if I want to run this, we can see now that these are being stored in variables. But so if I wanted to recall like, A1, because I worked on it as a, I can go into A1 and type A1 and I get them back A1, right? And so if I want to get stock price, I can do stock price, but I have to spell it right. And so 260. And so I'm using Shift Enter to run these cells. And so I do a lot of links here in the notebooks. They explain stuff better than I can. So this is talking about the PEP8, which is kind of like for Excel users, it's kind of like there's kind of like an agreed upon way people write Python code, which makes it easier. It's a little bit frustrating at the beginning, but it makes it easier later on for when you start sharing your code for people to read your code. Because one of the things that people say is, you read code a lot more than you type it. So if you write your code in a way that's kind of agreed upon, you can read code faster and everyone's happy. And so let's talk about variable names. So if I'm going to say some good examples of variable names, we're kind of explaining what these are saying. So these might be good examples. Notice that they're, the space and underscores kind of split words, and they kind of describe what the data we're storing is. And so we can run through these. These all work. And so bad variable names. So you can't use numbers. You can't start with numbers. And so we try to run this variable. We can't because we're going to get a error message. And yeah, so don't you can start with a number or underscore, but you can't start with a number. So if we were to change this to underscore, we could say that and it works. Okay. All right. So in this, this is if anybody can spot the problem here. There's a space. You can't have spaces in your variables. And so yeah. So if we run this, we get an invalid syntax. If we were to put an underscore in between, that would fix the problem, and that would work. And in this one, we've got a dash. We can't have dashes in variable names. If we were to change that to an underscore again, it would work. Okay, so here's an important tip, and I talked about this in the slide. There are a bunch of keywords that you should learn, or that you're going to learn that you shouldn't use as variables. Like you probably shouldn't use, I don't know, none as a variable name. I don't know if you can, but you can try it. But just kind of be aware that sometimes if you're getting error message, maybe it might be that you're using a variable name that you probably shouldn't. All right, so built-in functions. We talked about these in the slides. Excel's got built-in functions. You got a ton of built-in functions that we can use. We can actually see the full list here. There might be more than Python. I think there are. I mean, there are tons of them. And so again, Python has got the same concept of built-in functions, and they are automatically available to you without having to use the import statement. So again, in the slides, I highlighted a bunch of the ones I use all the time, but yeah, so all you have to do is call it. So in this example, we are going to run this, and so we can see here, we're going to use a length. So what's the length of this string in Excel? This is how you do it. It is the exact same in Python. I mean, it's pretty awesome. And so this outputs that. Okay, so here's a very important tip for everyone, and I didn't learn this until later on, is that, and one of the reasons why you should use an IDE is that the IDEs are really smart, and they can give you, they give you some really powerful abilities. And so what, say, there's a print function, and, like, okay, well, how do I do something? Well, you can actually use the keyboard shortcut, a Control Q, to tell you, and it'll bring up a help menu and tell you, okay, well, this is what you can put any type of values into it. But if you wanted to, you could specify flush as a Boolean, a true or false, and it will, it will flush the values for you. Or if you wanted to write to a file, you can actually do that. And so the control Q is a really helpful to kind of, if you're trying to figure out what one of these built-in functions do. And so if we look at Hello Python, we run this, and we can get the output Hello Python. And so here are some of the variables we initialized earlier, and we can run and print those out. We can also get the help print, and we can get a kind of a help. It'll tell you the help features of this. So again, this is an important concept here. Types, we talked about this in the presentation. Know your data types of your different variables and objects. Types is a very, very important concept to understand, especially when you get to pandas. And so we can actually figure out the type just like in Excel. We can figure out what the type is. This is a type string, and we use type 1. This is an integer. And the thing to know is that all of these different types, they all have different abilities. So a string, you can, just like in Excel, you can perform like a concatenation on a string. You can, do left on a string and get the first couple values. You can do that with Python. It's just a little bit different, and it's what we're about to talk about. And it's probably the most important point of this talk. And it is methods. Methods are very, very useful and important to know about in Python and in Pandas and everything. And the way to think about methods, in Excel, we have the luxury of using our mouse to perform actions on a cell. We can right-click on Excel, and it will give us a pop-up menu, and we can perform an action on that cell. So some things might be like, copy a cell, or it might be delete a cell, or it might be, change the font to, Times, or change the color of the cell. So we do that with the mouse in Excel. The problem is that we don't have that type. We don't have the mouse in Python. So how do you perform those types of actions on a variable or an object in Python? Well, you use a method. A method is your friend, and know about these, because that's how you interact with these objects. All right, especially in Pandas and everything. And so we use them, and it's just in methods. It may not make sense. Just kind of, get your note cards out and write down methods, and on the back how you perform actions on variables. Memorize this. And so we use a method by using the dot notation on an object. And then this is where the data types comes in above. Different data types have different methods. So a string has got different methods than a float. It's got different methods than a pandas object. And so you learn that over time, what those are. And I'll show you below a little tip on how to figure out what the methods are for different things. But remember that Excel, you can click, but in Python, you use a little dot. And I'm going to show you here in a second of what that looks like. So we have a variable hello underscore dot Python, which contains a string of text. If we hit the dot, and luckily, and this is something you write down on a sticky note and put on your monitor, is that you can actually, your IDEs will actually create a little pop-up menu and give you all the different methods that you can perform on whatever object it is. They're really smart. And so you can, in Jupyter Notebook, you can do Control Tab on a dot. So you hit dot, and then you press Control Tab, and it will bring up a little menu. And like, oh, these are all the different things you can do. So like, if you wanted to find text in a string, and there's a method for that. If you wanted to count the number of values in a string, there's a method for that. This is how you interact with the objects, and it's, I can't emphasize this enough. I'm going to talk about it a lot. So just to drill that in. So PyCharm has got this, but we're given the value of the variable dot, and then it automatically opens this up. And here are all the things we can do to this string, right? VS Code has got the same thing. You hit dot, it populates automatically, and here are all the things we can do. So we can do this here. We can do hello Python dot. So we can actually tab complete, but that we hit dot, and then we hit tab, And here are all the different things we can do with a string type. There's a lot of them. I only probably use about like 10 of them. But we can, you know, and it takes time to do all this, but we can do something like lower. You're probably familiar with lower from Excel. We can lowercase everything, right? We can actually perform methods on strings themselves. So we can, you know, this is just like a string, but you can actually perform methods on the string itself. So that's good. It's just, you can perform methods on anything and pretty much anything. I'm sure there are exceptions, but you know, if you wanted to uppercase this string, we know the string, we can uppercase it using the uppercase method. Again, different data types have different methods. You can't use upper on a number because you can't. This is not possible. You're getting an error. So another way that you can kind of understand to look at the different ways that you can different methods you can perform on a variable is by using the dir built-in function. This is a built-in function. You can ignore all the double underscores, but you go down here, this go kind of, and I use this a lot to kind of point out here all the different things you can do with a string. Lower, you know, you can figure out, you know, count, center, and so this is the last section, last portion of this, and this is another important concept, especially with pandas, indexing and slicing. So you will see this in pandas, and it's important to kind of, this is basic stuff with strings, but the same concepts are used in pandas and a couple other places, and lists. And so it's important to know about indexing and slicing. And so we can go into, and we can, first we want to figure out the type of the strings. So we know we can do certain things with strings because it's a string type. We can actually index into, it's called indexing. You put square brackets at the end of your variable and you hit 0 into infinity. And it will type, this is going to get you the first key in this string. If we wanted to grab the first 5 keys, we use the little colon here in between the numbers we want to specify. And just a reminder, in Python, we start at index 0. And yes, that is how we get the strings. And, you know, we can also use, like, if you want to get like the, you know, we can actually use negative numbers to index into strings. So this will give you that. Okay, so that is that. I think we covered that. We do have another notebook we can run through. I think we can take a break, maybe. It's been 60 minutes. And I think we can come back and we can work on the second section, or the second notebook of this section, and then just start from the third section. So it's just been 6 minutes and I need to get some water. So if that is okay with everyone.
Sounds good.
Okay. Yeah. And I guess I'm going to get some water. If anybody has got questions, let me get some water real quick, and I will be right back.
Hey, Ryan,
All right,
it's Jaylene
Yeah.
again.
Hey.
So real quick, I noticed, you've
Yeah.
got about 3 hours of material,
Yeah.
but it turns out that the tutorial was only scheduled for 2.5.
Oh, really?
Yeah, but they
Oh.
said, I asked the organizers, they said you could run long, as and people can stay if they're able to.
Okay.
But if you are able to
Yeah,
reduce.
maybe I won't get them, but maybe I won't get to this section. Can you see my screen?
Yes.
Okay. Yeah, I ran over on this part one a little bit,
Well,
and so I'm going to cover this. Maybe I won't touch on because 3 is a lot of slides, and so maybe maybe we spend majority of time in these two areas.
Okay. Yeah, and I don't want to cut anybody, short on material. So
Yeah, and
we'll see how it goes.
Yeah, and yeah, I wasn't planning on going through all the slides, and then I was like, oh, okay, well maybe I should. But yeah, there's every I guess I probably should have give people like 5 minutes or something, but I think we started at like 3, a couple more minutes. But I'm going to cover this. I don't know if I'm going to, maybe we save the challenge problems for after. And I might do a break after this part 2, and then we jump into this and see how far we can get. So that's probably, I think that's game 5. And maybe I probably let people do the challenge as we take a break for this section.
Okay, sounds good.
All right. Does anybody have any questions or comments or concerns about what we've talked about so far? Is everyone just like shocked at like how amazing these Jupyter notebooks are, I guess? Yeah. Okay, cool. You want to go faster? Let's go faster. I was hoping I was a little worried I wasn't going fast, and I was going too fast. So that's good. Yeah, if you want me to speed up, I can go faster. All right. And so we'll give you like 2 more minutes, 3:07, and we will jump into part 2 of the notebooks. And this is kind of a little bit, this is kind of a lot of not really interesting. When I think about when I started Python, like I could care less about this stuff. Like I actually debated on how I was going to do this presentation. I was like, oh man, do I really want to do this first start? Because all I cared about was like, was like, how do I do real stuff? But, what I found is that over time is that like, understanding methods, and that different variables that you have different methods, and understanding that there are different, that this is really important to understand, especially when we get to pandas, because that's all you use. Use them a lot. You also use index and slice. And so the reason I talked about this stuff was because we're going to see that a lot in this. And it's not really methods. You don't really have methods in Excel. Okay. And okay, yeah, Jupyter notebooks for ML. Okay, good. Yes, Jupyter notebooks are awesome. I honestly, I don't, just for everyone, I don't develop in Jupyter notebooks. I actually develop these in and you'll see in the second section, I just open up a .py file and I do all my development in there. I actually have to copy and paste everything into a Jupyter notebook, because I thought, Jupyter notebooks are really good for doing presentations and stuff. And so just know that and Jupyter notebooks are great for getting started, very forgivable environment. But again, we'll see in the second section is I just open up a .py file and I just go through the process, and we'll talk about it in a second. Okay, so it's 3:07. Let's jump into the second part here. Yes, I do agree. Even though, so I actually use both VS Code. Comment is VS Code. It's a nice Jupyter notebook. Totally agree. I actually like them better than PyCharms. I use both VS Code and PyCharm for different reasons. I really like the VS Code PyCharm, and it's fine with whatever with PyCharms. But yeah, I definitely like the VS Codes. And I actually like the add-ins, all the add-ins available for VS Code. Okay, so let's get the second part started. So if you go to our Jupyter notebook and we open up the section 1, 2, files, lists, and dictionaries. So these are basically all of the things we're going to talk about in this notebook. And again, I'm going to point out some important concepts. And we don't have any slides. We actually talked about the slides already. So we have no slides for this section. So important concept, I definitely recommend you get familiar with lists and dictionaries. And I really like the site. Again, I just found this online, but you can actually go in here and run some code and, kind of see how dictionaries work or lists work, and same thing with dictionaries. And we can actually see, so here are those methods. Remember, we're talking about methods. Here are the things that you can, and so list is a data structure, it's a data type list. It's got special abilities that you can perform on the list. And so here are these methods, right? Here are probably the most important ones. So a list, remember, we can store multiple values in a list. And so one of the ones you see a lot is append. So you might want to add, you have a list and you're like, oh, well, I just want to add an orange to the list. And so what append does is it adds a value to the list. And so this is a very important concept for lists. There are a bunch of other ones. Access stuff. You can go through these on your own. And if you need to refresh your memory, you can do that later, but we're going to kind of go ahead. With the dictionaries, they're a little bit, they got the same stuff. Here's some for loops. And so in this first section, so we're going to get started here for this. So the first section here, if you look into the Spreadsheets data folder, I have got 2 files in here, and these are the files that we're going to be working with in this section. We have one file. It's a PyCon sponsors.csv file, and it contains just some, these are all the sponsors for PyCon and what their sponsor level is. And we also have some tickers. So I like finance and I find finance interesting. And so I added a ticker column for all the companies that are sponsors. And so, so what we're going to do is I've got another file. And that file has got a bunch of sponsor levels and the amount they donated. And so if you're kind of like put 2 and 2 together, is like what we might want to do is like do like a VL lookup or something with 2 Excel file, two CSV files, but with Python, right? And so if we were going to do a VL lookup, we would do like, we put like a VL lookup, we would reference this cell visionary and reference this table here and pull in the amount, and then we could figure out how much money these companies donated to Python and PyCon, so we can all send them thank you letters, thanking them for supporting our favorite programming language. It's just I was trying to think of a simple example of interesting example, and so I need to reference this. So we can see here we actually got an error message. It says PyCon sponsors file name is not defined. It's because I didn't run this cell. And so you have to run cells before you can reference the object, or else it doesn't understand what that variable is. And so if I run it again, it works. And so again, you might want to get used to doing this type. We can figure out what type it is. This is just a string. It's a string file type. So we can, we remember we have a bunch of things we can do to strings using the methods. And so we're not going to do that yet right now, but and so what we're going to do eventually is open up these files and read the data. And so I use file paths a lot for working with data. And so just to kind of give you an idea of what the file paths are going to eventually look like, is like, if we were going to, if we wanted to read in a file, we'd have to find the file path of the file. And this is kind of, you can kind of think of this as like, of what we're shooting for. But we're going to use some packages or modules in the standard library to do this for us. Because as you'll see in the second section, we're going to automate this, some of these processes. And so just a reminder, for pre-installed add-ins in Excel, we need to go to the little add. Sometimes we, if we don't have an add-in enabled, we have got to go to the little button here and enable it before we can use it. And so we're actually going to make use of the standard library here. And so just to remember, we got to enable it before we can use it. Right. And so this is how you do that. It's Python. There's a library or module in the standard library that comes installed already in with Python. We have to import it and then we can use it. Right. So this one does import sys. We could run this and say it'll tell you what system you're running on. And so here are some links. Again, I'm not going to go into this. You can spend time on this, and if you want to dig deeper on what like a module or package and library are, the difference between, here's some links. But we're just going to kind of forge ahead here. So the standard library, very important. There are a ton of modules or libraries in the standard library. Here are some links to kind of get you started. This is a great book here. Python Standard Library Examples for Developers. His website is also great. Again, I'm just going to link stuff because they can do better. But if you go to the website, this is what you get. There's a ton of stuff. So I don't use all of them. Here are the ones that I use a lot, most often. And so I use the OS module. We use the OS path. We use the tutorial. Glob is another one. So these are kind of like, I don't know how many there are, but these are kind of the most important ones that I use. And so if you're interested in kind of getting a sense of, what are the actual real packages being used, here's a list. And then I kind of give you some advanced what the concurrent ones are really interesting when you want to process a bunch of data, and definitely worth looking into. But it's like a next level thing. Once you understand the basics, then maybe move on to concurrent and stuff. And so with this example, we're going to make use of the OS library in the standard library. And the OS, it gives us, it gives us a lot of functionalities we can use to identify file paths. So our problem we're trying to solve is we're trying to create a file path so we can read our file. And so we can import the OS, and then we can use that dir built-in function to figure out the functionality of, all of the functionality that we can do on here. There's a lot of them. But again, there's only about like 10 or maybe on this one that I use often. And one of them is to get the current working directory of where we're located. Basically, it's where this Jupyter Notebook is located. And so right now I'm actually in the temp folder because I cloned this down to check the repo earlier. So, but if I had used the problem is if I had used this up here, if I'd used this file path, I wouldn't have worked because this one doesn't have the temp. So the reason that we use this this library is that it will help us generate the file path that we need dynamically. And so actually here's the path right here. And so that is that. And yes, this is what we're shooting for. And I actually didn't run this one up here. Sponsors. I think there's an S in this, so it's maybe like a mistake. How did I name this one? Sponsors. Oh, file name. That's it. So I don't have to fix this one, but I don't know. We'll figure this one out. We'll just ignore this for now. And yes. So we can actually use another thing we can do is use the os.path.join to create a file path dynamically. And so we can actually so what we're doing here is that we're using the path.join. We're giving it the current directory, which is this file path. And then the data is in the data folder. And then we give it the file name. And then so we can dynamically generate this file name and then use this when we run the file and we open the file. So that's what that's doing. And so if we run these, we can generate the file name and we will use this in a second. Another another method or function that I use in the OS library is the exists. So we can check if the file exists. And so this kind of tells us that that there is a file there, because you can kind of use this as a check to see if like you had the correct file path name. And so here's an if statement, kind of like Excel. We've got the colon here, so we have the space underneath the colon. And then this is an if else. So saying if the file path exists, print file exists. If it doesn't, print file doesn't exist. And so if we run that, it says, okay, file exists. So we have the right file path, right? And so it's definitely worth checking when you're working with files to make sure the file is there, because you'll get an error eventually. And so we're going to run through opening a file. And so it's a three-step process. We need to open the file path. We need to read the file contents, and then we need to close the file. And so like everything, we can use the help built-in function to kind of give us some guidance on how to use the built-in object or any object. And so it's saying here we have to give it a file name, and then these are optional arguments that we can change if we want. So if we wanted to change this, the default is R, which is read, but if we wanted to write, we change that to a W. But then there's a bunch of other stuff, and you can read that. And so we're going to do this real quick. And so we're going to open up the PyCon sponsors file path. This is going to give us a file object. We can actually figure out what type of object it is, and we probably don't need to know what that means, but you can do it. But the more important thing is that we can actually use our favorite dir function, which tells us all the different things we can do with this variable or object that we have no idea what we're doing. So we actually go through like, okay, close, read. Okay, so this is what we're looking for. So we want to read, we're going to read the file contents. Remember that was step 2. So in order to use that, we need to type in the file name, dot, method, and then use the read in parentheses. And this is going to read our content of the file. And so if we run that, we just read the file. I may not know it, but we can run the, and maybe I should have cleared the output, but clear, I don't know what that's going to do, but and here's another thing is, so we actually read the file twice. So we have to make sure we run this again. So we run read, type, dir, file read, and then sponsors. And so we've read the data. And so this is actually the data that we got from we just read the CSV file, and it's actually a string, we'll see in a second. But remember, there's a step 3 for files, and we need to close it. Otherwise, if you try to open it in like Excel, you'll get an error because they'll say it's in use. So that's one thing you got to watch out for. So if we, this is what we named the data. We read the file. Here's the contents of the data. If we print it out, it looks really nice. That's what the data looks like. But it's a string. If we do the type on it, it's a string. We really can't do much with a string. I guess we could replace some stuff, right? We could, so here's that. Since we know this is a string, and we know that strings have got a bunch of methods that we can do stuff, we use the dot to perform a method. And so one of the methods on strings is that you can replace stuff. So we could replace, maybe we want to replace symbol with ticker, right? So we run this command, it's going to go into the string and replace symbol or symbol with ticker. And so that's just one example of things you can do with a string. So another thing we can do with a string is like find the location of a value in a string. So, there's a find method on string types. And if we give it a parameter, Microsoft, because we're talking about Excel, we can find the start location of Microsoft, right? And so it's saying here, it's given 372 values into the string, Microsoft shows up. And so what we can do with this, again, here's the slicing thing coming back from the first section, is that we can actually specify this number, and we can figure out where Microsoft is in the string, and we can basically print out that, starting with Microsoft. So, by finding where Microsoft is, 372, we're able to figure out where to start the string with this. And so we can actually go in here and say, so we can see here that Netflix is probably, the Netflix ticker is the next line after. So we can find the location of Netflix, which is 402. And so if we put those numbers, again, we're using the slicing here and indexing. If we specify the start row or the start value and the end value, we can get Microsoft. And I think this should be, yeah, mine at 402. That's wrong. So that's, yes. So I put the wrong number in. But so basically we have a row, right? So we have a row and we can do stuff with this row. We could save it as a variable. Fix this one. And so now we've got the Microsoft string as a variable, and it's still a string because we can run the type on it. And so we still have all of these different methods we can perform on a text. Like, for instance, you know, this little /n is a new line character. And so if we print this out here, and it actually print the new line at the end, so there's a space here. And so this can kind of cause problems. And maybe we want to, you know, get rid of this comma here too. We could actually just change this to one more value, but we can also use the strip method to strip the /n on the end. And then maybe if we, and so we can actually chain values. So if we can do strip, we could actually do like replace, or maybe we don't want to do replace because that's going to cause that to mess up. But you know, maybe we want to store this as a variable here, and we're going to do a print here to Microsoft. And also on the IDEs, we hit tab, it'll autocomplete for you, so you don't have to type all those letters. And so actually I'm going to change this to one more to get rid of this comma, so that we get rid of that comma, because it's just going to make things not work like I planned that. So we got rid of this comma. And so we can actually, another method on strings is this concept is a split. So we have a string now, and we can use the split method on the string to split values into different components. And so we can actually split this into a list. And so if we do the split method on this, it actually splits. So the default on split is it's going to split by spaces. And so if we specify a comma within the parentheses here, we can actually split on comma, and we can split that into you know, Microsoft Corp and then Visionary into two separate. So maybe we want to work with it you know, separately, and it's just easier to work with that way. And so if we want to, so here we're just kind of displaying the output. We're not really saving this as a variable. And so here I'm just saving this as a variable, and we'll call it Microsoft list. And like I mentioned earlier, the lists have got, you can index and slice on list. And so I'm asking for the first component or element in a list, and it's giving me Microsoft. I could change this to 1 and it will give me Visionary. And so I can actually specify like colon, and it will give me both of them. So like if I don't specify a value, it will, yeah. And so, yeah, so we have that. And we have this, change this. And so we have Microsoft Corp, we have the name, and this is 1. And we have the sponsor level. And so that's just kind of like some indexing. I need to fix some of that, but then we have the, like I mentioned, we above, we used kind of like the simple open method where we had to do the 3 steps. We had to open it, we had to read it, and then we had to close it. So the preferred method in Python is to use the with statement. And what this does for us is that it automatically closes the file for us, so we don't have to, we're not responsible for that. And that's kind of and that's gets in the concept of context, and that's for a different talk. But just, you know, if you're going to open a file, just use this way. Make sure to indent after the colon. And what this is doing is reading the file path, and it's going to read the data, and we're printing the output. So this is what this is the other file. So we have 2 files. This is what the other file looks like. And so we can print out the values of just that variable. And this kind of gets into like the concept of strings, and that's another talk as well. And like you see these little new line statements, you see like it's weird. So we're printing it out here and it doesn't show any of these, but when we just give the value, we see all these flash ends and it's not print. So this is the concept of like a raw string. If you want to look into that, it's important to know, and you will get things when you start working with strings. And so it's important to know. I'm not going to talk about this, but we can ignore that for now. But so we look at this data, we can actually look at this raw string data. We can see these spends. So why not, why not try to split, because we know that in the CSV file, each of these represent a row. And there's a little, at the end of each of the rows, there's a /n. So why not try splitting on that /n value? And so if we do that, we actually split the rows into separate elements. But we still have a problem here. We've got, we still have our values in the rows being separated. So that's not a problem because we've done this before. We split on a comma. And so this is where indexing and slicing comes in, right? So if we wanted to index the first item in the list, which would be the header, we would get, if we use the first index, we use 0, we are going to get the first element. And so we can print out that element. So we're just doing this for an example. And so if we have the item and we split on comma, we can split that. So we're like, okay, so we can split this one. We can split this one, but how do we kind of like, I don't want to go through and split all of these different elements one at a time. And like, how do I figure this problem out? Or like, is there a faster way, right? Or is there an easier way, right? So this is like the concept of for loops, right? So we have an action that we want to perform on a bunch of different elements. And so what the for loop allows us to do is basically go through one element at a time, perform an action. In this case, we want to do the split on each of these actions, and then it will, and then we can save it as a variable. And so, and then save and use it later. So this case, we're going to go through each element in a list, and we're just going to print out the item, right? Print out the item. And so we could do like, I don't know, we could have another print line. So, and I recommend people mess around with this, like, hello. And so we're actually, so this is actually what's happening. So we're seeing that we're getting the first element, printing it, and then it runs the hello. So this is, it's like, we call it like iterate. It's iterating over the object is how it's said in Python, but we're going one element at a time, doing something to it. And then, so that's kind of the for loop. Again, when I first started doing this stuff, it was a little bit difficult. So if you're having just practice, yeah, every day do 500 for loops before you eat breakfast, and you'll be good. So we can, like I said, we can, so we know how to iterate through each items, and we already know we can split these items. So if we wanted to perform a split on each of these different rows, we can split each of these elements into more elements. And so we are starting to look more like a table here in Excel terms. And so when we are doing this and we want to store this into a value, we need to create a variable. And in the case of data collections, such as dictionary and a list, we need to initialize a empty list or dictionary or set or tuple beforehand before we can add items to it. So just try to think through that process. So we have to create a list first before we can do append to it. So that's just something to be aware about. So what we're doing here is it's the same thing as above, except for every time we get to the end of this loop, we're going to store that value into a list called items. And so this is where we're using we know this is a list, type list. It's got a method on it called append that allows us to add elements to the list, right? And so that's what we're doing. If we run that, we can, so now we've got like a list of lists, right? And so, data collections are really awesome, but really power is when you, yes, it would be faster to make it a dictionary. There's a question. I'm trying to keep it simple first. I think I use this. I use a dictionary later on. I was trying to keep it simple with the for loops because the dictionaries are a little bit. But yeah, dictionaries, I use dictionaries a lot, but trying to keep it simple. So we have this list of list. And like I was saying, really get like power in Python data collections is by using multiple collections. So a really great one, especially for pandas, is like a list with dictionaries inside of it, which we'll see in a second. Because pandas loves those. You can basically pass a list of dictionaries into pandas, and it will turn it right into a data frame. Yeah, trying to cover some basic concepts again. Not a lot of this was apparent when I first started using Excel, so I'm just trying to cover some of the basics too. And so, luckily, if you were paying attention earlier and you looked at the standard library, you saw that there's a CSV module that comes standard with Python. So all of this work was for nothing. I mean, I'm just joking, but we can actually parse. We can actually kind of read in CSV files really easily with this library in the standard library. Here are links to it, and so like if you wanted to look at it, it tells you about it. And so this is it's kind of like this is almost like what we just did, but it's got examples in the documentation, and you can actually run the help function. But so we're starting simple. We're building it's a little bit more complicated now, and so now we're going to use the CSV module comes built in with Python to perform the read in the CSV file. And so this is a little bit more complicated example. We saw this in the slides, but we can go through this step by step. So we've seen this open statement before, and remember that we have to indent after the colons. So that's why we are indenting, and it has to be aligned, or else you're going to get an error. And so with the CSV reader, if we look in the, again, if you look at the examples, we can, it's saying this is how you use this thing, right? And so here's the CSV file. We have to use the CSV reader. We can specify a bunch of stuff, but it looks like this is right, but we can see here that, I mean, we just copy and paste this and we could use it. But we need to use the CSV reader to read in the file here. And then we can perform a for loop over the rows. So let's try that out. So I'm also using another built-in function here called Enumerate. And Enumerate, again, this is getting a little bit more advanced, but Enumerate basically lets us create like row numbers. It spits out row numbers when we iterate on objects, as you'll see in a second. And we're actually calling two values here, separated by comma. Again, if you wanted to look at how iterate works, you could do a help function on iterate, and it will tell you that it will tell you how it works. And so if you're interested, definitely check that out. But just know, you'll see it more in a second too, but what's happening here is we're reading the file. CSV reader is going to read the rows, and then the first is going to be the header. We don't need that right now, so we're just going to skip it. And so then we're going to perform a for loop over the different elements in the list. So if we remember what our data file looks like up here, this is what we're using. We've got this is what it looks like here. And so we can kind of say, okay, well, we're going to get a row, and we're going to get another row, and we're going to get another row. And so this is kind of like iterating for the list. We're going to skip the first row, and then we're going to be left with this row and then this row. And so that's basically what's going to happen in the for loop. And so let's go back down to our data here. And so here's the for loop. So we're iterating on the rows. We're just going to print it. I do that a lot. And just to kind of see what happens, print is awesome to figuring out what our data looks like. We can actually see here what it's going to look like. And so when we start iterating on this, we are actually going to get, and we actually use a /t here as a tab. So you can see how this is tabbed here. That's just in strings, you can specify /t, and it will tab automatically. /n will create a new line. So that is why this is returning on a separate line. And it's good to know, because one of the challenges coming up in for section has you got to make use of these little string values to to display it. And I use them all the time to get the output looking nice, and so I can kind of understand what's going on. So what we're doing here is we're printing the values. And so we can see here with the square brackets that the row here, row value, is actually a list. And so we know with lists, we can index into list. So if we wanted to get the sponsor level, which is the first value in the list, we specify 0 and we save it to a variable. So we can call that sponsor level. Again, we can just think of it as going one iteration. And then the for loop is basically just going to loop over all of them. And so we can specify the second element in the list, which is the value. And we're actually using the int built-in function because this has got quotes around it, which means it's a string. And so if we wanted to perform like a calculation on it, we couldn't perform a calculation on strings. We need to convert it first into an integer. And so this is what we're doing here. We're converting a string into an integer. It's good to know this because it comes up sometimes. Pandas automatically convert stuff, so you don't have to worry about this, but it's good to know. Again, the reason I'm covering a lot of this stuff is to make you aware, because sometimes you're going to run into things where like, oh man, how do I do that? And so that's why I think understanding the fundamentals of Python it's important, but not like, you don't have to know a lot, just to know a little bit. So we save these variables on the first iteration. So we've got those there. And so what we're going to do here is that we're actually going to create a dictionary of these objects or of these values. So we're going to specify a dictionary with the curly braces. And remember, the dictionaries have got a key and a colon and a value that you need to specify. And so we are just going to call this the sponsor level because that's what the column name is. And then we're going to call this the amount because that's what the column name is. And we're going to save these into a dictionary, a new dictionary. And then once we have that, we can store that dictionary into a list, which is the list we specified up here. We have to specify that first. Maybe I put this like here so you can see it better. Let's see here. See if we didn't run this before and it's saying that, and again, these errors are kind of ugly. Sometimes it's saying name error. Name PyCon sponsor level is not defined. Well, PyCon sponsor level is a list, and so we need to specify a list. I just put this in there, that's why I didn't run. But if we specify a list, it should run, and it does, thankfully. I never know sometimes. And so what we just did there is we created a list of dictionaries with the CSV module. So we read in the file. Read in the rows with the CSV Reader, iterated through each of the rows, stored them in a dictionary, and then stored that into a list. And, if you wanted to go into here and just make sure that your spacing is correct, I mean, we could do like sponsor, and this is really where you like learn how to do stuff is like just mess around with these examples. So here I'm printing out the dictionary before we append it. And so now if I run that again, we can see the dictionary here. And if we wanted to print the list every time, we can do that too. Do whatever you want, print PyCon sponsor levels. And so you'll see, the first iteration starts at 0. Here is the row values. And so we can start to see this list being built up. So this is the first iteration. And so we did that on the first iteration. So here's the second iteration, which is sustainability, 90,000. Here's the dictionary. And now we're appending it to the list. So we print out the list again. We can see that we now have 2 dictionaries. And so we're going to do this how many times? We're going to do this 7 times. And so you can kind of start to see how this is working underneath the for loop. So on the 4th time, we've got all of the dictionaries from the 4 above. And at the very end, we're going to have this dictionary, and it is a list of dictionaries, right? And so this is really awesome and really powerful, especially when you get to pandas. So if you're ever like trying to create definitely create lists of dictionaries. And you can kind of think of them, like, again, this is coming from a CSV file. So you can kind of think of these dictionaries as the keys being the column names and the values being the row values. And so we've got the column name, value, just kind of think. So yeah, dictionaries are great, but sometimes they don't really display very well. And so this is where one of my favorite built-in parts of the standard library is this package called Pretty Print. And what Pretty Print does is it makes your print statements pretty. It's exactly what it does. And so if we give the preprint our variable of dictionaries, it actually prints it out nicely. And so, I use this whenever I'm working with dictionaries because it displays the data so I can get a better sense of whether or not I'm doing something correctly. And so when we're importing some of these modules from the standard library, we can actually use the from and then from preprint import preprint. And so this will get rid of us having the need to specify preprint twice. And so so it's just kind of like a way to shorten the function that we're using. And so it'll work now because we use that. And so we have this, we can check the type of our list of dictionaries. It's actually, so it's a list. We know lists can do certain things. So one of the things we can do is we can slice and index elements of a list. And so just to kind of practice this, we want to get the first element in the list. And we're going to get a sponsor level. And we get the first element, which we know is a dictionary here. So this is element 1 because of the comma. So this would be element 2 because the comma, it's separated by the comma. And we can save that first element as a dictionary, and we get and we check the type. It's a dictionary, and so we're going to talk about dictionaries for a second. Dictionaries are really important. You can do certain things with dictionaries. They're different from lists. They've got different methods. Certain things you can do on a list that you can do that you can't do on a dictionary. Important to, again, at the top of this section, I put some examples and documents that you can read and figure out. I definitely understand the difference between a list and a dictionary. Dictionaries have got different methods. So they've got a keys method. So the dot keys will give you the keys in the dictionary. The dot values will give you the values of a dictionary. And the dot items will give you both the keys and the values. And so you can actually, if you wanted to do a for loop over a list, you can do for item and key sponsor level dot items, and then print item and key. And this will, we forgot the N, and this will iterate over each element in the dictionary. So this is how you might want to access a dictionary. It's good to know because it's sometimes, and I probably am not doing a great job explaining this, but just know that like if you need to work with it, just look it up and yeah, definitely spend time doing this. So if we wanted to create a dictionary, we can actually, we can create dictionaries two different ways, probably more ways, but we can specify a variable, and then with the dictionaries, we use the curly braces, and then we need to specify a key, and then here's that colon again, and then the value. And so we're specifying a dictionary with 2 keys and 2 values here, a sponsor level and an amount, and here are the values. And so if we run this, we will print out what that dictionary looks like. Another way, which is also a very it's very, I found many times that it really allowed me to write really clean code, understandable code, is you can actually specify a dictionary ahead of time, and then you can actually specify the keys by indexing into a dictionary, and you can actually access elements this way. And I'll show you in a second, but we can store those values, and it's going to create a dictionary the exact same way. And if we wanted to access one of those levels, if we do sponsor level, just to see what happens. Again, this a really great thing about Python is being able to interact it like this. And so if you actually try to index a dictionary like a list, you're actually going to get an error. You actually have to specify a key value to access elements in the dictionary. So if we specify the sponsor underscore level, we get the value. And so that's good to know. Functions, I'm going to briefly touch on functions. And we can think, because they're kind of similar to Excel. When you have a function, we can, basically the print statement we have is a function. We specify an input and it prints, it does a value. So say we wanted to replicate kind of a sum like we get in Excel, like, we've got A1 and A2, we just want to sum those values. This is what would that type of thing, or what type of function would look like. And we create a function by using the DEF keyword with a space. And then like variables, you can't start with a number and you can't have spaces, underscores instead of spaces. And then this is where we're specifying the name of the function. And within parentheses, we are specifying the input. So in this case, if we wanted to sum two values, we need to give it two values. So we put those inside the parentheses, separated by a comma, and then a colon. And then within the, and there's that colon, so we know we need to tab underneath the colon until we're done what we're trying to do. So we specify the elements, and then those elements are available for us to use within a function. And so what we're going to do is, since we know 1 and 2 are integers, we can, we could write a thing here that says below, it says A1 plus A2, and we could get the sum here, but we're just doing this for example purposes. So, you can kind of think of, we're making these values available within the scope of the function. And they're only going to be available for when you run the function. So if you try to access sum outside after you run this, you're not going to be able to access sum because it's going to have a short time span or lifespan. And so after function runs, it's going to not make that available. So that's basic function. Again, if you're coming from Excel, I think functions weren't too difficult for me. If they are, I put documents at the top explaining functions so you can look at those. But if we were going to run our function, Excel sum, we're looking for a 3 here. Hopefully we can get that. So we store those values, we run our function, A1, and we get that value. And so if we actually wanted to, and it probably shouldn't call this sum because that's actually a keyword in Python. But luckily this is within a function if we're not messing anything up. But so if we wanted to call this total, we can actually run that, and it's going to save the variable in a variable, and so we could actually call that up later to use it. So if we wanted to say total, now we have got total. If we wanted to, and again, you mess around with this, say hello, now it'll print hello every time and the value. And so we're actually saving the value here. You see hello or it runs because it's going to print hello after it saves the value, and we're storing the value. Yes. So that is, I don't know how to explain that. All right, so date time. This is another thing that comes up often with Python and objects. We have got a date time with working with dates. In Excel, we work with dates, and sometimes you have to convert them into a date object in Excel to perform different types of calculations or display it properly. And so Python it's good to know about this, the date time module. And in the standard library, we have to import it to use it. It's a pre-installed add-in, it's there, but we have to enable it first. So we create it. And so we actually can go here and see, we have to run this first, and then we get, okay, now what we can do, we can look at the type here of the datetime object, and it's actually going to give us a datetime object. And so it's just good to do this stuff. If you're just trying to learn something for a new time or for first time, we can also use that dir function again, and we can see all the stuff that we can do on this object or variable. And so you can ignore the underscores for now, but you can kind of see there's a lot of stuff we can do with this time thing, this time object. We can create like a today, if we wanted to get the today, now. And so it's good to kind of know because it's going to come up sometimes. For example, I did not save this as a variable. And so for this example, I'm going to save the .now as a variable. And since it's already been run, and we can see what that .now looks like. And so it's actually a datetime object, but we can actually perform if we print it, we can actually see that the datetime object will return a string of the value, which is the dot now. And we can actually, another thing we can do with, it's probably should be a new one, but another thing we can do with datetime objects is convert a datetime object and then convert it to a string. And so here we're specifying this is a month, but we could also specify like, the year. And this is something that I always have to look up, but I've used enough that I know. And if we wanted to specify like a year, month, date format, we can actually specify month, lowercase is important, and then £, lowercase d, and it will specify date in a string object. And that's what the string formatting is, an F, and then there's a P one that says parsing of values. Okay, so all right, so that's the end of section. That's the end of the second notebook in section 1. So let's take a break, 5 minutes, and we will go through the second section, which is the real Python example. And yes, so if anybody wants to take a 5-minute break, we'll come back and run through the second section. Are there any questions? Any comments, concerns, thoughts? Anybody wants to share? Ran over a little bit of time, so yeah, maybe not get to the third section, but and I don't know if the third section is going to with slides, airflow. But the second, I think, is probably spend maybe the rest of it on the second section. Yeah, the CSV. So I'm reading some of the comments. It's important CSV is pretty cool. Yeah, it's a little bit of work to work the CSV file. Pandas makes stuff really easily, so I don't actually use the CSV module that much, but it's cool. I have used. There have been certain circumstances where I have this like really like badly formed CSV file, and I need to use the CSV file, and so it's really helpful because you can you have a lot more. You're not confined by Pandas, which is sometimes a good, sometimes a bad thing, and so the CSV module is definitely cool. And again, there's tons of these things that are available. I think I covered that in the first section. And so we'll start this back up at like, yes, the second section, we're going to do real examples. So we're going to be working with an IDE in the second example. Is there a method to compress time within Jupyter? Is there a method to compress time? Like, oh, is that a joke? That's a funny one. I don't know if that's a joke, but I don't know.
It is a joke, I guess.
Is it okay? I'm a little slow sometimes with jokes.
At some point, if you just point me in the direction of your Flask projects, project, not necessarily whenever you get a chance.
Yeah, no, that's in the. So the Flask project is a simple one. I need to add the. There's a really cool Flask one called, and I forgot to add that to the list. It's called like Flask, GitHub Flask, and it is a awesome Flask. I think these awesome lists are really awesome.
Yeah, I wrote it down on my notes here, so I'm going to check those out.
Yeah, there's a really, really great one. Let me see what that's called. Yeah, the Flask project is in the Flask folder. And it's a simple
okay.
It's just a simple example. And so what I did was, and it's not related to the data we're using. I was going to plan on doing that, but
you don't have to go into a lot of detail. I just wanted to know where it was. I got it.
So it's in the Flask folder. And so it's a little bit. It's an RSS. It's just like with Flask, we get into it. It's like it's just a function. And so when we hit the route, it's going to pull in a. This one uses it goes to a XML RSS reader file, and we use feed parser, and we use Pandas to read that and display it on the screen. It's just a simple example. And
that's cool.
And we talk about it. But Flask is really awesome. And there's a lot of stuff you need to, and with Flask, and try to keep it simple. with the format, and there are some static files and templates, and we'll discuss that. And so we will start up at like 4 o'clock. See some of these comments. Like, yeah, see, the problem is, so I like Jupyter notebooks, and I don't develop in Jupyter notebooks. Maybe when I started, I used Jupyter, and then I moved on to like VS Code, and then moved on to PyCharm. I actually do all of my development in PyCharm, which you're about to see in a second, how I do that. And you can use VS Code if you want. The process is the same. So right now we're running a little bit over, but you guys can look. So we don't need that one, but can. And so this is really probably what we'll spend the rest of the time on. And if we want to jump into the breakout section, I can go over this. I don't know if it's going to get recorded. And so this second section, we will be using an IDE because that is what I use. And I wanted to keep this, when I thought about this section, I was kind of like, should I put it in a different notebook? But when I think about when I first started Python, what I try to do in the second section is I try to do this as real as possible. And so I wrote the code in a very linear fashion in one straight Python file. And so we can kind of think about it is that like I developed this tool that I'm going to show you in a second that's going to download some data from the SEC. I ran through that, and then after I kind of get into a format that I'm looking at, I am going to I do this thing called refactoring, which is kind of as a complicated word for saying like reorganizing your code. And so we'll maybe touch on that in the second part, but yeah. And he agrees. So yeah. And so this is still running. Give it another minute, and then we'll go.
Ryan, so one of the participants was wondering if she could open the file that you're just to follow along in PyCharm.
Okay, so yeah, so I'm about to show that, Lisa. So I'm going to show you how you can do that. And this is how I do all my projects. And so we're at 4 o'clock, so I will walk through how I'm going to set this up, and we can do the same thing with VS Codes. It's the same process. And so we're going to start the second section. We're a little bit behind, but that's fine. So in this section, we are going to go through a data set, and we're going to use all these libraries. And so let's get started. And so I've got PyCharm. I like PyCharm. You can use VS Code. I'm using PyCharm Professional. I like it. You can use the Community Edition. It's fine too. I don't think it has got Jupyter Notebook integration, but that's fine because I think VS Code is better in my opinion. And so we can open up this project. It will work. So go here. Professional. So it's opening on my other screen here. So if we close this project, I'm going to get this on my window. So here. So if we go open PyCharm, we can kind of see some of my projects I'm working on. And I just clicked on it. So we can actually go to open, file open, if we have a PyCharm open. And then what you want to do is you want to click on the folder of the spreadsheets, the data frame. And I would recommend if you're going to work on the problems or work on any of these, I would recommend just opening the top level folder. And because you have access to all of the stuff. It is really, it's probably the best way to work with this. And so we have the project open. And so I just opened this folder for the first time with PyCharm. We can kind of start seeing a couple things. We have down here, we can click on the Python interpreter. So I have got, we already created the spreadsheets of DataFrames. So I'm going to set this one real quick. Okay, I'll make the font bigger in a second. So we can actually specify an existing environment, which is the spreadsheet, the DataFrames one we created earlier. We can make it available to objects. So now we've got the environment that we set up earlier. I unclicked the Conda because I can just use pip for stuff, but Conda is nice for creating the separate environments. And so I don't know how to make this. I don't know how to make this bigger. I can make this bigger. But if we look at the directories now for all the of the GitHub project, we can see if we close all of these folders, this is the top level directory here. And so which one we are, so I actually, maybe afterwards, so I actually have a couple challenge problems that I do in Python specifically. Again, I just think working with the Python files is a lot easier. I don't know, I find it a better way to work with Python. And so if you're interested in kind of some challenges for the first section, which is kind of pure Python, I've got a couple of challenge problems here. And it involves like working with a list of dictionaries, and I give the answer. Don't look if you're going to do it, but there's 3 challenge problems. Again, I'm happy to discuss and help anyone after. Yes, it's on section 2. Oh yeah, so okay, so the so in the README file of the in PyCharm, this is going to so the problem what we are going to on section 2. So this is what this is going to be the file. So here's the answer. This is going to be the file. Section 201 real world example.py is what is the file we're going to be working on. And you can actually, if you pip installed all the packages, you can actually work along here. And so we have about 55, I don't know, actually, yeah, 55 minutes to work through this. But so, so this is the file. Again, if you want to go through the README here, README's there. But this is the file here. And this is the file we will be working on for this. So, so we can close tabs to the left. And so this is the file. Okay, so to give some context here, let's take a look at what we're working with. And so I'm going to open this up. And so the SEC has got a bunch of cool data sets available. And so I'm big into finance, and I recommend, like I said at the beginning, I recommend if you want to get good at Pandas or Python, is to go to the awesome data set list that I give in the second challenge. So after this section, I have a challenge, and go find a data set that you find interesting. I know people in this tutorial are from all different industries. Find a data set that's specific to your industry and just start work and maybe do what I'm about to do. And I can almost guarantee you're going to get a lot better at Python and Pandas or any library. Because you're gonna have the knowledge and understanding of the data set itself. And so I like messing around with financial data from the SEC. So they actually have got some financial data sets here, which has got some financial metrics in it. So if we look at this, we can what we're gonna do is we have this file, and then we can save this. We're going to save this to a folder that we've created in the projects temp. I think we're in this folder, and we're going to create a folder here called zip files. And so we'll just create that there, and we'll save the file down. And I've used this program. It's really fast for downloading stuff. And so we have the file, and we downloaded it to the zip files. And I'm going to do this all in Python next. That's just the reason why I'm doing this. Just to show that the actual process that you do this by hand is the exact same process in Python. So when you're thinking about writing the Python code to automatically do this for you, the steps are the same. So I'm going to do the exact same thing in Python in a second. But say I wanted to look at this data in Excel, right? I want to look at this file called num, right? It's 333 megabytes. Let's see what Excel has, right? Let's see what we can do here. And this is, so we are opening. So try one of the following steps. Okay, so I got an error there. Let's try to maybe, I don't know, something wrong's here. So let me try this a different way. Projects, temp, zip files, and extract to. Let's try this one more time. You know, I know Excel can do this. Let's try it this way. All right, got it. Okay, so we're opening the file. All right, it's opening gnome.txt. Okay, just give me a second. It's working. Hold on. Still loading. And it's taking. Oh, data set is too large for the Excel grid. Oh, that's interesting. Okay, so we're actually going to lose some data. So maybe it's fine. We can just, you know, we can work with it. I guess how many rows does this have? This says, oh, okay, so it only has 1 million rows. So we're only going to get the first million. I think there's about 3 million rows. So it's one of those things about Excel. And so I actually did a part of this because just want, you know, there's reasons to use Python on Pandas and there's reasons to use Excel. I know there's another way we could get this data into Excel, but I'm just not gonna, yeah. So we have our data. This is what the data looks like. One of the files, there's actually a couple different files here, and it's all like financial data. And actually, this is a really good data set. We can see that it's got separate rows. So we touched the concept of tidy data. This is really great data. And so there's one row for each value of data. And so we're working in Excel and we're going to do this in Pandas in a second. But maybe one of the things we might want to do is, I don't know, find a row that we might find interesting. And so we might go into here and say we want to look at revenues. Revenues might be, I know it's different. Actually, it's not. Oh, actually it is. Okay, didn't worry for a second. So because we don't have all of our data because we only got the first 1 million rows out of 3 million. But you know, revenues, if you're not an accounting nerd like I am, revenues is like is the amount of money that a company makes. And so to calculate, so you can think of revenues as like a lemonade stand. You know, how many lemonade drinks are you selling? So that would be revenue or sales. So you could take, so calculation to generate revenues is like products times the price of the product will get you the net sales number. So we can see here that sales, these are different filings, and it doesn't really help us here. So, you know, maybe we want to, there's another file. So there's another file that we're going to basically use from VL lookups here in a second, which is called the subfile. And the subfile is basically a list of all the companies. And so this one, we're going to do a VL lookup in a second with Pandas. That's why I'm showing this, just to kind of give you some context. But we can see in the numbers file are the numbers. We have these little ADSF. This is actually the filing number, and this is how we're going to associate the filing with the name of the company in a second. But we can actually go into here and do a filter and bring me back to my Excel days here. And say we want to say Microsoft. So these are only public companies. And so not all of the companies are going to show up. So if we do Microsoft, we can filter by Microsoft. And we can get Microsoft's different filings that they created over the course of the quarter. And this is just like a descriptive file. And so in this file, we have got like the address for Microsoft, the city, just like, you know, general like information about the company, the date the filing was filed, and so the form type or the different files. So this is the data type or the data we're going to be working with in Pandas. Again, you can use, what you should do is, if you're not again, to go to that awesome data set list that I'm going to show at the end, and find a data set that you like and try to perform these commands on data that you're interested in, because it's going to be, one is going to be make a lot more sense, and you're going to be able to do a lot more stuff with the calculations and all of that stuff. So definitely, I wrote this in a way that you should be able to change some of the keys and the values. So, you know, just doing a little bit of adjusting on the on some of the code here, and you should be able to get this to work. And again, I'm happy to help. If you guys want to do the office hours and bring some data, I can help you get started. I'm happy to help wherever I can. So that's always an option. All right, so to the code. So we, again, this is, I wrote this from scratch, and I wrote it in a very linear fashion. And this is how I would develop something like this to automate the data downloaded to transformation, the generation of, I didn't change anything. So, and this is where the interactive terminal, I use the interactive terminal all the time. And so what you can do is, you select the files, and you in PyCharm, the command is Shift Alt E, and what that is going to do is going to send your selection to the interpreter. All right, this is probably like the coolest thing about one of the coolest things about Python. And so we actually ran the code and in the interpreter, and I really like this better than using Jupyter Notebook, just because I have a lot more flexibility. But and you'll see these comments here. I commented this out. So if I actually run this, it's because it's got comment, it actually doesn't run, but I can actually run these commands separately inside the comment. So I requested the python.org site. It actually ran, and I actually don't have pretty print imported yet. So pretty print import pretty print. And so we're going to run this and pretty print the content, and that's the Python website. So we actually, with this command, you can actually select it, run it. Hopefully they don't mind. This is for educational purposes. So if we remember when we first started, so we're going to do that process. We're going to walk through that process we just did, where we went to the website, we downloaded the file, we extracted it from a zip file, we read it into Excel, and we did a filter on Microsoft. And we did, in addition, we're going to do a VL lookup, and we're going to do some other cool stuff too. So this is how I started this. So first thing I usually do is I got to get the data, right? First thing you got to do for building like a data pipeline is you got to get the data. Here's the URL. I saved it as a variable. I ran it. So if I bring it up here, again, it's PyCharm I like a lot. So if I actually type zip tab and hit tab, it's going to autocomplete, so I can see the value, and I can actually see the values of my variables on the right side here, which is really nice. And so I don't actually have to keep doing print and type and all that type of stuff. So, and so again, I'm doing Shift Alt E, and I'm running this line. And so I ran this line, and it's printing out. And so we're going to speed this up here. And so remember, I've got this file name, and so we're getting into request. Request is a awesome library, and in the GitHub homepage for the project, I link a bunch of resources for request, and I'm also and so what we're doing here is we imported request here. I'll just probably do this closer. We pip install the request first before we can use it. So, if you want to install this, you need to do pip install request. And then it's a third-party library. Once you install it, you can use it. And it's just like an add-in. If you want to use it, you got to import it first, right? And so if we give one of the methods on request object is a get request. And a get request is basically how you download stuff from the internet. And we did that with the PyCharm website. We can also do that with a zip file. So if this is the URL, put these closer together, and we run this Alt Shift E, run request.get. And so we're actually downloading the file now. We re-downloaded it. It is a 48 megabyte file. So we downloaded it, and it's saved in this little object here. And so we can actually do a dir on R to see what we can do here, and you can kind of see, it gives us a bunch of stuff that we can perform on that object. We can actually go into the interpreter here and see those objects in real time. It's going to take a second because the file's kind of big, but so Alt Shift E runs the file. Okay, so we have the file, and we need, what do we need to do with the file? We need to save it somewhere, right? And so this just kind of gets into the part with file paths. Okay, well, okay, let's, we know we have the OS module can help with us. We did this already. We can go look at the code if we need to, but, you know, I already did it, so you don't have to. But, you know, reference this stuff because there's a reason why I chose these examples is because I'm going to use them here. So we can use the OS module to get the current working directory. Yes, I think I tried opening that. Maybe not, don't click that R because it's trying to read in that 48 megabyte file. And it's trying to figure out what it wants to do with it. So maybe not, don't click the little R for now. So I just restarted the terminal, ran those again, so we should be good. We have the OS, so we've got the file, we downloaded the file in memory, it's just sitting there, and we got to save it somewhere. So we're going to use our friend OS module in the standard library. We're going to get the current working directory. Right now, our directory is here. We can get the base name, which is the file name, by using the ospath.base name, and we can print that out. And so we can start seeing some of this stuff populate automatically, so we don't actually print this. But right now, we know the base name is the file name. And we created that zip folder, but we can use the ospath.join and the current directory to create a file path for the zip directory, so we can run that. Again, I'm just thinking real innovatively here, like, you know, we're going to have to save this file someplace. So let's check and see if this folder exists. Folder doesn't exist, so creating one. So this is an example of a knit statement. We're creating the zip data folder. It created it. So if we go into Explorer now, we can see that there is so this is my Explorer zip data just got created. So now we have the zip data folder. That's what that one did. And so what we can do now is we can use the ospath.join again to create the file path for the zip file so we can save it. And so this is, you know, so this is what we're going to save the file as using the request. And so, you know, here's some links to context managers and binary files. So we are going to write a file to our local drive using the file path we just created. And if you know here, before we're using R to read the data, to write the data, we're going to use WB. And the reason we use the B is because a zip file, unlike our CSV file, which is a text file, it's a string. It can be parsed. The zip file is actually a binary file, and so we actually need to specify B as in binary to save the contents to. Otherwise, I don't know. It might work. I actually don't know what happened, but you can try that on your own time. And so I actually just ran that file here, and it just saved the file. So this command here just create this file. Watch, I'll do it maybe in like slow motion if I can. I don't know. I think this is helpful sometimes to see, like, I'm saving the file, and there it is. It's saved. So we have that file, and you can go on YouTube later and watch that and watch in awe. Is that like, man, did I just do that? It's kind of how it feels sometimes. Yes, you just did that. Okay, so so now we have the zip file in our folder, right? Zip file in our folder. We need to get access to that file. So luckily there is a zip file library in the standard library that we can use called zip file. You know, great name, right? And what we can do is that we can give it, there's a method called zip file, a function or method on the zip file import that we give it a file name, and it will open up the zip file in a way that we can extract the data. And so we can run that line, and we can, you know, but first we probably want to create a directory for this file, for these files that we're about to unzip. And so we can use the, since this is if we go to type and type type on this is a string, we go over to here, zip file locate. So what we're doing here is that we're replacing just the zip on the file with nothing, and then we're going to use that as a folder name. And so we're going to store that as a variable, and we can shift Alt E, we can run that and see now we have a folder location. And we can use the extract all method on the zip file from up here to extract all of the contents into that folder. And we can watch that in real time as that happens and be amazed. So now we've got the files in the folder for us to access, and we're going to use glob. Glob is one of my favorite standard library. And what glob does is it allows us to get all the files in a directory. And so if we give this, so this is what the this path is right here. So if we give glob, we import glob, we can use it, and then .glob by looking at the documentation, we can give it a file path and then specify the folders we want to look in. So we're saying look in the folder underneath, and then would give us any type of file that's in there. If we were to specify like .txt, it would only return .txt file. So it's a really easy way to get the files in the folder. So if we want it, there's one HTML folder. So if we change this to HTML, HTM, I think, and we get the one HTML file, and it's actually a list. We can see the square brackets, and so we can actually, if we wanted to, index into it if we wanted to get some practice. We could get that first file, but you can do that on your own time. So we have that. So we're going to get the files. And what we're looking for is this num file. And we're interested in the num, we're interested in sub, which are, contains all the company information. And here, this contains the number of files. And so we are going to want to work with these file paths because we're going to want to read this in with pandas. And so we can create a file path. And so this created a file path. We added the num.txt, and we created that file path, and we created a sub. And so now we have a file path. And so here we get some pandas action. All right, so pandas is awesome. And again, I wish I could have spent, there are plenty of tutorials on pandas that I put into the links, and that you can go through on your own. I definitely recommend it. Just a slight thing about pandas is really, you almost got to think about it like learning it like a separate programming language. It's the syntax in pandas is similar to Python, but it's almost like an entirely different beast. And so if it's difficult and you find it difficult, it's because it's not pandas. But I think hopefully with the stuff that I covered in the first section, you kind of have a better understanding of how some of the features and functionalities are going to work in pandas, because we're going to use methods, we're going to use slicing. And so that's the reason why I think, and that's something that I think some of the tutorials get wrong, or they don't do a good job explaining it, like why or how this stuff comes into play. And so I put some great tutorials on here. Brandon Rhodes has got a great pandas tutorial. Definitely check those out. And yes, and so I actually have in the repo, one last thing, you can look at this pandas Jupyter notebook, and it's got a bunch of basic functionalities that you can run through. I'm not going to go over that in this section. I'm going to go through real stuff. This is a real world example, but there's a Jupyter notebook called 04 Pandas that is definitely worth checking out, and it's got a bunch of basic functionalities that I'm not going to cover right now because we're using pandas for real. So pandas, awesome. Really makes life a lot easier, and you're going to see here in a second. Let's get started. So pandas, we need to import it. The common convention for pandas is to use the PD as PD. So we could import it like this in pandas, but then pandas is, someone decided that writing pandas every time is too much. And so we're actually just saving this as a PD variable. So instead of referencing pandas, we can just reference PD everywhere. Okay, so tip for pandas. I really do not like the way pandas comes out of the box with displaying stuff in the terminal. And so these commands here, I use these on almost all my scripts. And it basically just lets me see the data in a way that is, because I don't run this and I try to run this data set looks good, but if I've got a data set with 15,000 columns, it doesn't really look good. And so what these are doing is that it's specifying some default. So it's saying that max rows, I want to see 500 rows maximum. Otherwise it's going to return and it just does not look good. Number of rows, I want to see 500 rows. I want to see a width of 600 pixels. And so you'll see on the bigger data sets where this comes in handy. So here's that list of dictionaries we were working with earlier. And if you did the challenge, this is what you would this is the output of from the challenge. And it's a list of dictionaries with a symbol for the company. And these are all companies that are sponsors of PyCon, the name of the company, and then the sponsor level. And so if we want to run this in the interpreter, we have to select the entire dictionary. Otherwise, it's not going to run. And so if you select, remember, Alt-Shift-E, and this will run. And now we've got a dictionary of Python sponsors. And so remember when I talked about in the first section that Pandas loves lists of dictionaries? Well, they do, because you can take this dictionary. I don't know how long it took me to realize this, but like getting data into Pandas is a little bit tough if you're not reading from the CSV file. But if you kind of like think about it like a table, and that the values are the keys, and the keys are the header row, and the values are the row values. It makes sense, and because that's what we are going to eventually that's how we're going to be working with this in Pandas. And so we can take that list of dictionaries into a pd.dataframe, which is you can think of as an Excel table. And I actually talk about this in the Pandas example here. Or maybe it is, I don't think it's displayed, but you can just think about it as a table in Excel, one sheet. And so if we use so we can print out the DF companies, we need to fix this. And so we can actually, so this is one of the nicest things about working with Pandas is this data frame object. And the data frame object, again, think of an Excel spreadsheet, single spreadsheet, columns. We have columns and we have got rows. And here are the row numbers, and we call these indexes in Pandas. And so we're just looking at, row 0, and Python starts at row 0. And so 1, 2, 3, 4, 5, great. And so we can actually, I commented what this looks like, but we read this in. We can actually, one of the cool things about Pandas is that we can export data really easily with Pandas. And so if we take a data frame object like this, I only ran this part, I selected it. If I maybe want to save this as like a file, all I've got to do is use the method. Remember, we're talking about methods. This is where they're coming in. That dot to CSV. So if I do dot method, I hit, and it automatically populates. These are all the things you can do on the data frame object. There are a lot of things you can do on a data frame object, and it's really powerful. And it's going to take time to learn. And I'm in this tutorial, I'm going to cover on some of the ones that I use a lot. And so if you kind of go through this tutorial, keep in mind, so I'm going to go through a lot of ones, but one of the ones in here is to underscore, and then like a format that you want. And so there's one for Excel, there's one for HTML. And so we're going to use the CSV. And so if we do the CSV and do parentheses and just sit there, PyCharm will automatically populate, kind of give us like, hey, this is what you can specify as inputs for this method. And so I had already done this. And so I know the inputs for this. And so I'm just going to save this as a CSV just for whatever. I saved it. That's it. I saved it as a CSV. I can go into the folder and look at this. There's the file right here, and this is what it looks like. And so it's a really, Pandas is really awesome. So this is what we outputted in just one line of code with the file. Yes, with the import CSV file, you've got to go through a bunch of stuff. Pandas is just like one line. Okay, so let's go through this a little faster. So we have the import path is, here's this text file. Remember this text file that we couldn't actually read in Excel? There's too many rows. There's 3 million rows. And so let's see what happens with Pandas, okay? Let's read in that file. Remember, it took like, I don't know, like 15, 20 seconds. Okay, so we just read this in about 3 seconds. And so we can actually, and we're specifying delimiter because it's a tab delimited data. And so we can actually, now we've read this data in, and we can print this out and see what the data looks like. and it looks exactly like Excel. So we can see here there's actually 307 million rows. Took us like less than 3 seconds to load into, and really this is where you start seeing like why Python and Pandas is so powerful. You can work with data sets that are large and do a lot of stuff. You just have to, learn some of the basics on here. And again, the dot method that we talked about in the first section is really important because that's how you are performing actions on a data frame object, right? And so if we just kind of bring our friend type in here, df_numbers, the reason we can see that this is the data frame type. So this is a data frame type. So we can do all of the actions on a data frame. So Pandas data frames have a bunch of cool methods. There is a .info method, which basically gives us kind of a summary of the data that we have. We can see that these are integers here, and these are objects, values, or float is a float. Remember, we talked about floats and integers. There's a difference between these. And so remember, we had 2 files that we're going to work with. The submissions file _path is the submissions of the company names. And this has got just a bunch of information. Remember, we looked at Microsoft and found Microsoft. This one's got 17,000 rows. And the head here basically shows me the first 5 rows of it. Here, you can actually chain functions. So we could do head 1, which is going to give us the first row. And we can actually do dot again, believe it or not. You can dot again, and you can actually do a bunch of, you can still do things on the Pandas data frame that you could do before. So one of the ones that maybe we want to view this data sideways, right? And so we're saying, give us the first row and then transpose it, right? And so that's what we just did. We just took the first row and we did it sideways. And that's just the functionality that I use a lot. Here's the submission file. We can look at this one and see there's a ton of values. So there's 35 rows, all different types and stuff. And so this kind of gives us an idea of what our data looks like. And so we actually, I'm actually going to convert this. So if we look at the SIC row, which is the companies are organized by the industry they're in, and the SIC code is the industry number that they're in. And so I'm going to do something in a second. I'm going to join 2 data frames, which is like a VL lookup. And so when we do the data frame joins, we need to make sure that they're same type, that they're both strings. And so what we're doing here is that we're converting to an int64. And I had to look this up because I tried converting this to a string, right, but it wouldn't let me. So I actually looked online and it said I need to convert to int64. So now if we go in here and we look here, it's an object. Before it was an integer. And so what we can do here is, so we have the submissions. It's like 36 columns, right? It's 36 columns. I'm only interested in like 5-7 of these. So here, okay. So remember we talked about strings, how you can index into strings. Well, you can index into data frames, right? You can index the data frames, and when you index into a data frame, you can actually specify you actually get the columns. And so in this case, we need to use 2, it's a little bit different from strings, but we're going to use 2 square brackets, and then we're going to specify the column names. And so what this is going to do is we're going to take those 36 columns, and we're only going to show us the columns, these columns. So we're going to save that as a variable. And so now we have a data frame of just those columns that we're interested in. And so kind of like, this is, I did this because there's just too many columns and I didn't want to see all of them. So I don't need any of those. So here are some examples here. And so we can actually filter on a column. And so what we can do is we need to import the re here. I think I did it before, but say we wanted to look for, so we have a column here that's the name, which are the company names. And we wanted to find what row Facebook is in, right? So what we can do is we can use, and then this takes time to learn, but if we look up online how to filter a column in Pandas, it'll show us an example like this, and that's how you find it out. But it is possible to filter. So what we're going to do is we're going to convert this column to a string object, and we're going to do another method that says contains, and we're going to say, if the row contains Facebook, return true. And so if we run this on all of these values, it says false, but little do we know that if Facebook is going to be in here, it is in there. And so what's going to happen is there's going to be a true on one of these columns. And so this is kind of gets into Boolean indexing with pandas. It's an important concept. I'm not going to cover this entirely, but just know that like whenever you're doing something to a column, it's like an if statement. So it's going to return. So we're saying if the row contains Facebook, return true. We don't see it right now, but it's in there. I think I'm pretty sure it does. But so we can do that. And so if we give those true values if we put these inside of square brackets, and there's some people can explain this better than I can, but if we put the true false column return here in square brackets again, what we can get is all of the rows that Facebook in. And so to kind of get another example, we can say Microsoft. And so we can see, oh, here are all the rows that Microsoft are in, and here are all the rows Amazon's in. Okay, so this is just one way. There's like 6 or 7 different ways that we can get filter columns. So let's see this up. So the other thing Pandas can do, so there's actually this URL that has got the SIC codes. So we've got the SIC codes, we've got the name of the industry. Say we want to like do a VL lookup on this, but this is a HTML. This is a table. What the cool thing about Pandas is that what you can do is you can actually read in a HTML table directly from the internet. And so we just did that, and it actually returns a list. But if we look at the values, it actually shows us it actually parses it, and it's a really powerful tool for a simple website. So if you have a website that you want to parse the table, you can actually give it the URL and it will parse all the tables for you. In this case, we know it's a type table, and the first element is a table that we're interested in. And so if we now we use df info, we can see that. And so we're about to do a field lookup on this. And so one of the things you got to do often with Pandas is replace the column names because typically Pandas or Python, it's underscore lowercase everything and underscores instead of spaces for key values and table column names. And so what we're going to do here is basically convert the and we're going to do a couple chaining here. So we're going to, and it's a string object here. So we can use the lower. But we have to specify string object again. Then we can use replace, which is another string, and then we can do replace again. So this is just converting the column names to lowercase underscores in one go. So this is what it's going to look like at the end. And we could specify the location of the columns in the data frame is dot columns. And so we can actually save the new column names into the column. So when we look at the column list now, we can see that these are lowercase now. So I could type 5. And so we could see what we just did there is that we renamed the column names. Again, I'm trying. I did this in one go, and this is how I would do stuff in real development. It's basically I need to get the column names because I'm going to join these columns on another data frame. So I want to make sure the column names are the same because it's going to look for that. And so with this new SIC code, I need to convert this to a string again because we're about to join the data on the data frames. But before that, we have another file that we're going to get that's going to help us with mapping. And so the data that we have, it's got CIK numbers. And so with this file, it's on the SEC website, it actually gives us its tickers. And so I want to be able to filter by tickers because I know tickers for far too many companies. And it's just easier for me. So again, I can actually read this file. It's a text file. I can actually read it from the internet if I give the right parameters. So this is actually going to do a request in the background. And so it saves a lot of work, but I think it's important still to understand some of the basics on how to do this if you don't have Pandas necessarily. And so I'm actually going to read this URL into a Pandas data frame directly from the internet. And we did, and that was pretty awesome, wasn't it? Yep, I can hear everyone going. So if we do head, we can see that the values of this data frame we just read in are the tickers and the CIKs we just saw. And one of the things we can do on the column is if we do the dot string.upper, we can convert all of the values in the data frame to uppercase. And so we're just going to convert them to uppercase and save them in the column. So we're specifying the column here. Again, here are the square brackets, again, for the indexing with the strings. And so with a data frame, if you specify, so if we think about the object here, if we specify the square brackets in the column, it kind of like works like a dictionary. And so if we specify a column name here, we can actually get just one column, right? And so we could actually, there's two columns here, I think CIK. So if we wanted to get CIK, we can actually see this. When you use head or the rest of the, so the question is if you use head, so if you use head, it's actually only going to perform the action on the first 5 objects. But if you do the head at the end, it will you will perform. It basically does it in order. So the dots that you see are in order. So if you do head last, then all the actions that you're going to take on that object are going to be performed. Okay, so one of the things we can do with columns, so if we do just columns here, again, I'm doing Alt-Shift-E here, nothing special. And so if I do, we can create a list out of the column names here. And so this is the submission file again, which has got, the numbers, or this has got the information about the people. And so here we're going to do another VL lookup on Pandas. And Pandas has got 3 ways. And if you're familiar with SQL, it's kind of like a join. There are 3 ways we can basically merge data frames together or spreadsheets together. One of them is merge. And this is actually a part of the Pandas library. It's not part of the data frame. It's a function or a method on the the Pandas object. And so what we do is, and we go into here, I'm going to cut this and I'm going to merge. And I wait here a second, and it's going to tell me kind of the inputs on how I'm going to merge the data. And if you notice, I mentioned before, the reason I was renaming all of these columns is because when I do this merge, it's going to merge on similar columns. And so I basically formatted the data in a way that allows me to do the merge. That's why I just did that for anyone interested. So what it's specifying here, so it says merge, I'm going to merge 2 data frames. So I need a left. So the data frame on the left is going to be DF submissions. The data frame on the right is going to be the symbol CIK. And so if I do this, and so there's a bunch of other parameters in here that you might see in a second, but how inner, you can basically use inner, outer, it kind of gets into the SQL joins and stuff. You can also specify on column, which is a column ticker, or like you can specify on specific values. And right now, Pandas is basically going to try to identify what column to join automatically. And so, so if we look at these 2 submission files, this is what it looks like before, and this is the other one. So basically, I'm going to join CIK from this column onto the CIK of this column. So what's going to output out of this is the symbols on the DFB submissions column. So when I run this, now if I look at this variable, we have the symbols column. So we just basically joined this little data frame onto this data frame and created this new data frame. So that's merge. Like a VL lookup, really powerful, really awesome. And it's really fast, and you don't have to do a VL lookup again or index match. And so we can actually specify the on. And so on this case, we're going to join 2 data frames, which is still the submission data. We just added symbol, but we're actually going to add the SIC list, which is the industry. So now what this is going to allow us to do is we're going to allow us to see the actual industries of the companies on this list. And so, maybe now, if I was thinking about like an analyst, maybe I wanted to see how many, and this is where knowing the data set comes in important, like what industries are growing the fastest, which industries kind of had a slow year versus last year. So I can do these types of really interesting, and then I'm going to show this in a second, but if I get to it, but so we're basically merging some of these data frames that I've been kind of preparing. We can actually, so if we look at this data frame, so like, okay, well, I don't want this column drop instance. We can actually delete columns using the drop method, and we specify columns. Again, we can look at the documentation, and we can see that we need to give it a list of columns. And so we know what a list is, and we know what a string or a list of strings. And so if we specify that and we run that, we don't have that column anymore. So we just drop that column. That's what it's called. And so maybe I want to create a new column, maybe I don't like the column order here. And I wanted to create, reorder the columns to make it more logical for me, right? And so there's a function on a Pandas data frame called reindex that lets you reorder the columns. And so I can give it a list of strings, and it will basically reorder the column really awesome, like quickly. We just did this on 22,000 rows. Here's before, right? We have title industry over here, and here's the new one. We have title over here. So basically, we also added symbol over here. So it's just for me, for like working with, it's going to be easier. So I reordered the columns. And so say we have like this company, we've got a data frame of companies here, and we wanted to get like just like a column, right? We wanted to get like the tickers from this column. We can actually use the toList method method. We can actually do dot here to see all the things we can do with the column. And one of them is toList. And this will convert a list of that column. So if we print this out, remember Alt-Shift-E is how we are sending this selection to the interpreter. And so here's another way you can filter data in Pandas. There's about 4 or 5 ways. And so say we wanted to take the tickers from all the companies in PyCon, and we wanted to take our submission files, which is all the companies that submitted filings to the SEC, and say we wanted to like find all the filings that all the PyCon sponsors submitted during this last quarter. And so we can use this .isIn, and it actually takes in a list. And so we created the list up here. And so we're given an input, and it's giving us one of those true false data frames again. There are some truths in here, but you can't see it right now because there's so much data. But if we take this data frame now and we wrap it around with square brackets. So here is the true false, and then we're putting square brackets around it and using the original data frame, we can actually filter to just tickers, to just the companies that are sponsoring PyCon. So maybe, now we could say, okay, well, we've got all the companies for PyCon. We have all the filings. Let's like look at some of the data. Let's look how much revenues they're generating or how much profit they're generating. And, we can kind of get an idea of, how well they're doing as a company. And maybe we could make a case for, if we're trying to get PyCon in our company, look at all these companies that are sponsoring at PyCon, look how well they're doing. Maybe we should start using Python. There's just different ways you can use this data. So we're going to save this. So we have a data frame now of the PyCon symbols. And we can drop duplicates on a data frame if we specify the column we want to drop. And then we can also, so we got 10 minutes left. So we can sort values. So I think this is enough. I think we're going to run out of time here. And unless we want to go 4 hours, we can do that. I think we might get cut off, but and we're probably not going to get to section. But basically, if you want to continue through this, you should be able to continue this. Yeah, I mean, we can go. I think I might get cut off. I'm down to continue this, but I think the video might get cut off. But I'm just going to keep going. And so eventually what we're going to be doing here is we're going to perform we're going to see kind of how well these companies that sponsor revenue or PyCon did this year and how much they grew revenue. And so that's kind of what we're kind of shooting for eventually. And we're about halfway through. And so let's just keep going. So submissions, so new column submissions. Yeah, we can go to the lounge and do this more, and then it can be a lot more interactive. But okay, so last 10 minutes. So cut off at 4. So I'm going to cut this off here. We can jump into the lounge and finish up this discussion. I do want to get to the challenge for this one, and I think when I look back at like the what really helped me take the next steps with Python was this type of project. And I can actually see that I've already done this challenge. If you look at my GitHub project, GitHub page, I've got this thing called the PySEC Edgar, here. So I actually, if you want to know why I'm so good at Pandas, and I don't know if I'm good at Pandas, I don't know. You can tell me what. But I actually created a little Python app that lets you download data from the SEC Edgar website. And I created this just to learn. And I found an interesting data set. And I created this project using data that I was interested in. And, you know, I got 40 people started. I mean, it's pretty cool. And yeah, so I definitely recommend that, you know, everyone try to do this on their own. So this is the challenge here for the second section. I basically tell you the steps that you have to go through to do this is steps I just was going through. And so my challenge to you is to create your own repo on GitHub, find an interesting data set from this awesome public data set list. There are tons of data sets. You know, if you go to finance, we can go and say, oh, here's SEC Edgar. So what my challenge is to create your own repo on GitHub, write a script that downloads and does some things with the data, and saves it and does an analysis and share it with the world, and have people will start it. And you know, after you get it, maybe refactor it. And refactor just means cleaning up your code and reorganizing your code. And if you really want a really great way to you know, better learn this stuff, you know, just do it yourself. Write, you know, here are the different steps you need to do. Create a GitHub repository, create a new project structure, write code to download the data set with requests, write code to transform and analyze the data set using Pandas. Write code to visualize data set. So, you know, try to perform each of these steps with the data set that you're interested in. And again, what helped me is really working on a data set that I was interested in, because I cared a lot more for the data. And stuff really, when I was like, oh man, I really need to get these two columns to add up, like, because I need to get revenues and stuff, you know, it's a lot more meaningful for data that you're interested in. For me personally, it could be different for other people. Yeah, so if anybody has questions, I think we're going to go into the breakout. You know, I had a lot more stuff. I was kind of worried that I had not enough stuff, but there's still, you know, go ahead and explore all of these different files. The section ones are the ones I made for this tutorial, and then the challenges. And so just to show you kind of like, you know, after I get done with all of this, we got the data, and I eventually get to the point where I can perform a year of sales growth on a data set, right? So that's what I was looking to do. And so I actually saved the output here. So you can actually see in this column here, if you could read it, but I actually took all of the companies in the data set and calculated the % change in revenue year over year. And so the reason I did it this way is because that in the second section, you can start to take advantage of, remember when we looked at the data set and we saw that there were multiple files available, if we go to the top here and go to this link, remember we saw this data set here and we did this one, but see, here's like where a for loop comes in handy. Like I just wrote code that downloads and extracts and does an analysis on just this one set. All we have to do now is just use a for loop and figure out the file naming convention, and we can loop through all of these files. And basically we can perform analysis on all of these files. And so that's really where, like, you know, understanding the basics can help you do like a real world example here. So basically in the refactored version, I actually write a program that will, when you run it, and so we can run it with if we go into terminal here and we go to Python, what is this one called? Section 2. What is this thing called? Section 2 _ 02. And we run this file. We'll see if this works. So what is actually, we're looping through all of the files right now. We're extracting the data. So I'm actually doing this request. So you can look at the code if you want. So I'm actually performing a for loop over each of those files. I'm downloading those files into the folder. We can actually see them right here as it happens. So it's going in here and it's going to start extracting these files. And so the reason why I did this in a method that I did was because because I can throw this stuff into functions, and I can throw it into a for loop, and I can basically perform all this stuff automatically. And that's kind of like the point of the presentation was, if you know a little bit of Python core basics, you can really do a lot of powerful stuff. And so right now I'm doing the extraction of the files into zip folders, and into folders. So if you can actually look at one of they're all the same file, and it's really great because these files are written this way. But I downloaded all those files, so I actually have an error here, and it's a bad zip file name, and that's not unexpected. But what will basically happen, I need to fix this, but it'll go through and extract all of this data. And you know, if you're going down at the bottom, it says there's a main down here, and if you give it a start and end here, it will basically perform all of the tasks that we just did, and it will do a transform data, and you can go look at the file. If we had more time, I could show you, but it filters out revenues, and you give it a form type, and then it will do a group by. So actually, you do a group by in here. Do a couple merges, yeah. So and again, we can jump into the breakout session after this, because it looks like we're going to get cut off here. But I'm going to jump into that, and if people have questions, or if we want to continue, feel free to reach out. My GitHub, my email is on my GitHub. So if you ever have questions or anybody needs help, GitHub, Brian McCoy, and yeah. So I think we're good. Thank you, everybody.
All right, thank you, Ryan. And then I also wanted to say a nice thanks to Ashley, our live captioner, whose fingers must be worn off by now. And so, yeah, if you go to the Hubilo platform, just go look for lounge, and then DataFrames is the lounge. And I see there's already somebody there waiting for you.
Cool. Thanks, everyone.
All right, thank you, everybody.
Thanks so much.
Thank you. Bye-bye.
Bye.